Hello everyone, welcome to ZaranTech. In today's fast-paced digital landscape, businesses require powerful database solutions to manage vast amounts of data efficiently. Let's dive into the SAP Native HANA. It's a cutting-edge in-memory database and platform that revolutionizes the way businesses manage, process, and analyze massive volumes of data in real time. It's like having a supercharged engine for your business intelligence needs. SAP HANA offers analytics processing up to 20,000 times faster than traditional databases, unlocking vast insights. In today's competitive landscape, data reigns supreme. SAP HANA enables businesses to not only keep pace with data but also drive innovation and growth, staying ahead of the curve. In this course, we will explore SAP Native HANA thoroughly, from architecture to applications, offering practical insights and best practices. But before we begin, please subscribe to our YouTube channel and hit the bell icon to receive regular updates from us. Now let us look at the agenda. Agenda 1. In-memory architecture. 2. HANA database architecture. 3. Projection node. 4. Union node. 5. Join type. Let's dive in.
So we are starting with the module 1, which is nothing but a basic introduction about what is SAP HANA, why we are using it. We know that there are so many platforms available. What is different in SAP HANA? So these are the basic questions we'll be covering up. It is important to know that all these things has copyright responsibility. So credit should be given if you are using it anywhere. Okay, so what is SAP HANA? It's a new architecture being created in 2012. We all know that before that, while reading your data, we are supposed to fetch the records from your memory, giving it into the your place where it can be read. So in that case, what was happening? It was a traditional system where whenever required, a record should be populated. It was fetched from RAM, then it was shown to the reporting areas. That was taking huge amount of memory, as well as the computation time was very huge, because it was supposed to hit database, read, and then do all the calculations. So to remove that latency time period, SAP came up with the new concept of in-memory. When we say in-memory, what does it mean? So with the in-memory concept, we are having our data real time store into memory, and we are directly hitting and doing our calculation in the database and showing it in the real time. That save a lot of time and even increase your processing time. Okay, decrease your processing time. In a very short duration, we can see the desired results. So in architecture, basically this has been achieved with the concept of multiple core has been introduced into the single chip. Okay, with the innovative in-memory concept, we are able to do a parallel processing because we have multiple cores. So each and every, let's say, we are going to explain it further slides. We are in the one table only. The one column itself can be processed and in the one core, and second in the another core, like that. So in that way, the parallel processing is happening with the help of multi-core, and we are able to show our data. Okay, and we know that for each and every application to be maintained, to be built, we need to write number of logics for it, right? And in this case, what we are doing, all those logics, instead of writing it outside your memory, we are writing in the memory itself. In that way, everything being written into your database layer. Okay. Then, as you can see here, some of the statements that SAP HANA is a main memory available, like main memory is been used so that we are avoiding lot of performance issues which we usually have in INO, your input and output devices. Okay, and then when we say that, okay, everything is in your in memory, so does that mean whenever there is a power failure we will lose the entire data? No. So what we are doing, we are having a data in your main memory as well as in your hard disk as well. So instead of, in the case of failure, a save point has been maintained, so the data will be stored and saved till the save point, because at each and every point a refresh is happening. Whatever there is a main memory is getting stored physically into your disk. Then another plus point about the SAP HANA is that it's a column and storage. So what does we mean by that? We know, like in each and every storage, it's a two-dimensional table, right? So we have rows and columns. So the only ways we can store the data is these two forms. I hope my screen is visible, right? So let's say we have a table having country, products, and sales. Then you have these values associated with each and every column. In the row format, what we are doing, we are storing the entire value for a particular country in a row format. Okay, in one row you have your US alpha 3000 and then so on. However, in the country, what we are doing, for each and every column, whatever is the value being stored in a one core, you can say, and then another column in another core. In that case, what will happen, the compression and aggregation, okay, will happen in a smoother and a faster way. I hope that is clear, right? So let's say there are some numeric value, the last one, right, where we have the sales, and we are supposed to do the aggregation on top of it. And then let's say we want some average value, or we want we want to do some mathematical operations on top of it. So on the aggregation value, it will be very faster. Instead of again checking in the row, okay, what was the value for a last column, fetching it from the row 1, row 2, row 3, row 4, and so on, it will be time taking. However, while reading your data in the column store format, your read operation will be faster. The main difference, whenever you are more focusing on your read operation, we are going to use the column store. If you want that the write operation should be faster, then we can create the tables with the row store fashion. Okay. Okay, so I have been using this word of parallel processing. What does that mean? So as we have seen earlier, that the column store, we have a single column, and then we are searching and doing your aggregation. Okay, and it can be done in the form of array, because everything is stored at a one place, right? And in that case, parallel processing is possible. And then we have a row oriented storage, where the same operation would be much slower. The reason being, as I told, it will be reading from one place then another place. So this is the reason, when you are going with the read operation, go for column store. When you know that we have to write maximum data and there is some calculation happening within the HANA to put it into some other tables with the help of procedures, then we will be going with the row storage. Okay, we got the example of parallel processing. So this is your column 1, column B, C. In that way, what is happening, because of the multi-core processing, each and every core is being used and utilized to do the calculation for one column. In that way, what will happen, your processing will increase. As simple as that.
Sorry, 1 minute. Did you share this document with us? This document is available to us?
That's right. It should be available. You might have received some link where the all the curriculum what we are discussing, all the PDFs will be shared with you. By now it has already been shared with you. If not,
Okay.
I'll check with the team. I'll make sure it is done after the call.
Okay. During training sessions only, is it accessible, or even after training over also we can able to access this one?
Yeah. After the session also it will be accessible.
Okay.
Because after the 3 days of class, we'll be giving some assessment questions. For that, you can go through this PDF and the links which are provided, and that will be easier for you to complete your task. Now, so it's again the same thing basically, that SAP HANA can deal with the scanning speed of a gigabyte. When we say gigabyte, several gigabytes, it's huge, right, per millisecond. So it can do a aggregation on fly, like we have just clicked. We want to view the data on, let's say, your SAP Web ID or maybe your Tableau application, any front end application, and you have records in lakhs, so that everything can be processed within a friction of seconds, and your computation can be done on fly. So here, uh, in the bottom layer, we have preprocessor servers and name servers. Okay, then we have index server. Most of your calculation is being done by index server. The people who already know and been reading about the SAP index server is the main part for SAP HANA. Then you have your web applications where we basically interact with the web part, and then we have your UI. Your UI could be any of the application SAP, from SAP world or from non SAP. Okay, these are the main 5 servers. Okay, the names we have already discussed. So let's start with the index server. So index server is the main server for the database, and index server is a process income from your all the SQL queries, what all logics you have written, all those statements will be processed by your index server. Okay, and it consists of an engine which actually stores your data. Okay, all the actual data stores and your processing's been done by index server. So with having said so, you can understand index server is the core server which is doing most of the part for your SAP HANA. Okay, then in a broader way, basically in index server, what do you have? You have your repository where you are storing your design time objects. Okay, there is a term which is going to come: design time objects and runtime objects. Design time objects are while you are, let's say you are creating your calculation view, right? And you are doing some drag and drop in your graphical way, or maybe you are writing some scripted calculation view. In that way, you are directly writing your SQL, or you are doing in the form of sequels, graphical view. All those technical objects, before you actually activate them, will go into your all those technical objects will store somewhere. That storage can happen on premises or on cloud. Okay, so that part is nothing but your repository where you are actually storing your design time objects. Runtime objects is that, okay, you have created your calculation view and now you want to see how the data look like. So you will be running it to view your data. That will be your runtime object. Okay, I hope that is clear. If not, then we are going to discuss later also about the same. So your design time objects are going to store into repository, which is again into your index server. Then you have your data engine where your exact data is being stored and you have your processing happening. Then you have your processes for typically for SQL thing, and you have session and transactions manager also. Session and transaction managers, as in that you are running, let's say you have more than one editor open, right? You are running like you are doing your calculation on in a one SAP HANA studio. You have more than one system, right? And you have opened different SQL editors or maybe different screens. In that case, for each and every screen, how the session is being maintained, when the transaction is doing what, all those things will be maintained by your this area of index server. Then we have preprocessor servers. These are nothing but let's say you have a raw data, and then in your raw data you need to analyze your text, and you need to extract the data out of your text. So all those search functions, whenever we use those functions, then your preprocessor server is being used. Name processor, as the name only suggests, it's nothing but let's say you have like a distributor server, and that server contain location about your server, where it is being stored, right? And what is the IP address and host name, and all those things will be stored by your name server. Okay, as it says, this contain the information about server on which your data is exist, because for adding each and every system into your SAP HANA, you need to provide certain details like your host ID and your name, system information, instant ID. All those things will be come under name server. Okay. Static server is nothing but where resources are being located and how the consumption is happening. Then access server is a very important server, which is again an important server just like index server. It is used so that we can interact with the outer world. Outer world as in that you have a UI, right? And you need to interact. Then API calls will happen, and SAP database need to talk with the another application altogether. So all those being done with the help of access server, where we will be doing some HTTP calls or these kind of stuff we'll be discussing when we are actually doing a hands-on. But on a high level, access server will be used for that application. So calculation views, we'll be covering what kind of calculation views do we have. um, mm, these are the topics basically in this presentation. We'll be covering in this module calculation views, creation of your calculation views. Then you have your VDM, virtual multi-dimension scenarios. Then what in the calculation view we have a type, dimension, calculated attributes, time dimensional, calculation view benefits. All these things will be covered here. So calculation view is some of you might be knowing that earlier when SAP came up, we used to have three type of views: attribute, calculation views, and your analytical view, right? When attribute views were used when you have only text data dealing, you don't have any measures into it. Measures are nothing but your numeric values, right? So when you don't have your numeric values, that time attribute views we used to help take the help of attribute views. And the analytical views at the other type is when we have measure values and we want to do some aggregations or calculations. That time we used to have those. But calculation view was doing work of both the attribute as well as analytical view. So what SAP suggested, let's not use those views until we don't have a calculation at all, or we just have a calculation. If both things are required, let's just make a practice to use calculation view only. Okay, in calculation view what we do, we can create drag and drop operations where we have multiple nodes being provided, your joins, attributes, projections. All those things we'll see in the lab time when we are doing a labs. And then we also can do a thing. We know that whenever a business requirements comes to us, it's not possible that we can do each and every calculation with the help of drag and drop operation features being provided by SAP HANA. So in that case, what we do, we write the SQL. Okay, within a calculation view also we can write a SQL, so that at the top level the data preview and consumption would be easier. But to write the logic, we can use the SQL script, because we can increase our a place where we can actually write our calculation. Okay, having said so, in calculation view script way also we have some drawbacks. So that can also be handled with the help of other technical objects which we can create, whether your table function or procedures. Okay, so as of now these are the two which are mainly being used. Okay, a very simple way in terms of creating your analytical view is typically setting up your parameters, what all parameters you can output you want. Okay, then defining your structure, and execute write your SQL queries or a graphical way, and then execute and assign your attribute measures and doing a data preview. Okay, in the calculation view you have calculation view basically of three type. As we mentioned, your SQL access, where your calculation views will be no multi-dimensional support. It will typically just doing your calculation directly from your SQL queries. The cube, when you know that you have data which is having a major value, your transactional data. Okay, there are two types of data, right? Master data and transactional data. So master data is nothing. Whenever you see that your table just have information, for example it's a employee data, where in employee you have your name, address, phone numbers, these kind of details are master data. which usually doesn't change very often during the full tenure of your stay in the organization, right? However, your transactional data is your salary slip. Your salary slip will be coming every month basis, and then your bank details where you are making your transaction on a daily basis sometime also, right? So in that case, those are your transactional data where each and every day, sometime seconds also, you are making your transactions. And then imagine if number of people are using the same organization, then how many transactions are happening on a daily basis. So those are called your transactional data. So when we know that in our requirement we are dealing with the multiple transactional data, that will be a multi-dimensional reporting. Okay, where analysis would be required, and you know that okay, you will be dealing with different compression techniques and all those areas. So aggregation will happen in that case, basically aggregation, right? So that will be your cube. It's a very known question being asked while doing your certification also, that with the cube, what is a default node? It's an aggregation node. Okay, then you have your star join. Star join is nothing that again, it's a somewhere similar scenario, that you have your multiple transaction data and a one fact table. Okay, fact table is nothing but your historical data, which is nothing but your master data. Fact table is also known as master data, which is not going to change very often during your tenure. Okay, so when we have one fact table and multiple transactional data, then and all of that need to be connect with your fact table, that time we use star join. I hope that is clear. So with the cube, with the star join will be your default node. Okay, then the words we typically use, as I have already used the word measure, right? We have attributes, dimensions, star schema, hierarchies, semantics. All these are the words which we will be seeing when we do our hands on. Okay, so measures is nothing but your numeric value. Attributes are your non-numeric values. Dimensions again is something similar. Star schema is a node which is provided when you are dealing with the multiple dimensional tables and one fact table. Hierarchies is a concept being designed here. Semantic is a top level layer from after which you can mask your columns, whatever you not want to show at the reporting side. So measure and attributes. So measures, as been discussed, it's a numeric value. However, your attributes are a element which is being used to design that measure. Let's say okay, so for example, you have again employee table. In your employee table, you have your salary, right? Your salary is your measure. However, the attribute which is being used to define is your column name, which is nothing but your salary column, right? So that will be defining your attribute. Okay, for let's say name Raghu, your salary is so and so. So this is how it has been defined. Example is measure is the number of products sold, unit price, total price, and your attributes is product ID. For one product ID, like Raghu, the value name is a column, and then value is Raghu. For Raghu, what is the salary? Okay, so here already product ID. Let's say product ID is 111. For 111, how many units has been sold? What was the per unit price? And what is the total price? Like that. Okay, all this will become your attributes, and this will become your measures. Then in dimensions, what happened? There are a number of cases where we are analyzing like your measures, and we need to do it in the form of group attributes. Let's say like order by, basically group by, right? So in that case, what we do, we have one dimension where we are saying okay, we want it at the country and region level. Okay, in one so one dimension would be a product key, product name. It's a set of attributes, set of your columns become one dimension. Okay, when you want that, okay, I want let's say your product how many goods has been sold out. Okay, how many goods has been sold out on the basis of product key, product name, product category, and supplier. Who is the supplier? So in that case, for one dimension would be your, okay, how many goods has been sold depending upon this group. If you are familiar with the SQL, you will be able to relate to this, that these values will come into your group by, and this is how one dimension is being prepared. We'll see further this into lab as well. Okay. With that, we'll come into star schema. In star schema, what happens? This is your fact table where you have your master data only. Then you have your dimensions, which will be having your measures values. Okay, so every one need to be have one or another relation before making it a final view, a final data preview. You need to interact with your fact table, so that, let's say we are taking column attribute 1 from table dimension A, then we are taking attribute 2 from dimension B, from dimension 3 we are taking attribute some other attribute similarly for D, but all of these are related to your fact table. So instead of having a fact table multiple times being called into your view, we have a fact table being called once, and then we are joining your different dimension table along with it. Okay, this is very good actually. When we start doing, we'll compare this performance if we have a similar thing being created by calling fact table multiple times, or using fact table as a star schema and then doing a performance check. There'll be difference. Okay, then your calculation views. Okay, hierarchies are the concept when we need to basically divide your data. Hierarchy, typically what does the mean of hierarchy word, right? Hierarchy is like, okay, first you have your let's VP, then the second hierarchy is you have your let's say okay, let's start with the bottom one. We have your software engineers, then you have senior software engineers, then you have your lead, and then you have your managers, right? So in that way we have a hierarchies. Similarly in SAP HANA also, when we want to deal with the data, where we have to give some sort of a hierarchies. Okay, first this level of data should be shown, and at the second level this kind of aggregation should be shown, which will be known as number of senior softwares in our company. Then we want number of senior your team lead into your organization. That way, on a single calculation view, we can have our hierarchy being maintained. Okay, for that reason we use hierarchies. Yeah, so they have given example also that we have a region, these are the three regions, and country. Then for you have hierarchy in the base of these regions, and then within a region for country level also you have grouped your data, Germany, UK, and so on. Okay, this is how hierarchy been maintained. Semantics are your top level layer where you are maintaining, okay, this is your attribute, this is your measures, and these will become as a percentage, like that. Again, this will be more covered in your lab part.
Hey there! Want to master SAP Native HANA? Our course is here for you. Take it at your own pace on our platform. In this course, you'll dive deep into SAP Native HANA. It's like a toolbox for managing data, from organizing supplies to streamlining operations. Our course covers it all, from basics to advanced techniques, crafted by seasoned experts who know their stuff. Your teachers are pros with years of experience. They're here to guide you and tackle any queries you have. And guess what? Our students love it. Folks just like you have found our course incredibly useful. The best part? It's budget friendly. You get top-notch learning without breaking the bank. Ready to become a SAP Native HANA Pro? Sign up now. For more info, head to ZaranTech's website.
Okay, if this is visible to you, what typically happens during the calculation view is, in calculation views we create a virtual model, right? We are not we are not actually creating any physical table. When we say physical table is like we are storing your data from the raw data and into SAP memory. We are not doing that. We are just creating a view on top of it, that okay, we want to see the data with so and so column and those columns are been maintained in separate tables. We want to join them, we want to do a calculation top of it, and then we want to make it ready so that when it been consumed by a UI, your UI could be anything, Tableau, Web ID, boards, or anything, right? So whenever it been consumed by analytical application, then your calculation view is created. So in database layer, you have your physical tables, then your calculation view, and then it has been consumed by your operational reportings. Okay, so it's again the same thing, like how it has been used. You can go through that. Okay, time-based dimension calculations. Time-based is basically you have your mm, calculation where each and everything should be done on the basis of, let's say, monthly or weekly. Okay, then the aggregation and those things will happen accordingly. So whenever that defined event will occur, then only that operation will happen. Okay, let's say we want to aggregate how many goods has been sold out for a month. Okay, that logic we will define in your view, and then that whenever that event will happen, your calculation will happen, and data preview, when we do the data preview, accordingly data will be visible after the aggregation. Okay, these kind of views are being called time based views. We usually don't use them because it's not required that often, but yes, it's one type of it. Then why we are creating calculations views? First thing, these are very easy to create, very easy, because with the help of calculation view, SAP has already backend defined how the performance should be handled. When we write the SQLs, there is a chance that we may write some SQLs which are time consuming, right? However, with the calculation views, SAP inbuilt has designed in such a format that the performance will be optimized as much as possible. So in that case, the performance is very good. Another is reusability, that one view is not that you are going to use it only for one application, one part of the requirement. You know that, okay, similar requirement is been used by another part of the application, you can reuse. It's a reusable product. And then flexibility, adaptability, easy to transport. Each and everything which we are going to create in your SAP HANA, it's very easy to transport. Just capture your TR, transport request, and we are ready to move it into next environment. So very easy to transport as well. I hope this theoretical part is been clear to all of you. If you have any specific questions as of now, you can let me know. Otherwise, I hope once we do the labs, most of it will be cleared. Let's say we are adding another system. Okay, so for adding any of the host details, there are two ways. That is it a single container or it's a multiple container. There will be multiple container means that within a dedicated SAP HANA storage, we have divided that storage to give one place to multiple areas. So in that case, it become multiple container. Okay, or it could possible that only the entire storage has been provided to named as one container. So basically to split functionally, okay, area wise, we create either the multiple container of the same memory, or we can make it as multiple containers. So when we create multiple containers, for each and every container itself, the tenant database would be different. Okay, so in that case, we will go with the multiple containers, then provide a tenant details, and then we go ahead with the descriptions and everything. Okay, here you can provide, as you know, right, earlier I was providing the IP address, or you can provide the host name itself, which is nothing but your alphanumerical URL kind of a name being provided. Okay, instance number, and this is how you do it. So these are the two ways. We are into the system now with the tenant ID. Okay, so when you need to create your procedures table functions, okay, where you are going to write your scripts. Okay, for that you are requested to use your modeler perspective, because you are going to do actual modeling where SQLs are requested to be written. Okay, however, if you are just creating your views, okay, that time you can use your systems itself, okay, which is nothing but this perspective where you can check the objects with your content or catalogs. You are not you are not required to go into your repositories anyhow. When we talk about the business people also, business people are just requested to use this perspective only. They are not requested to go into deep development perspective anyhow. Modeler is just to view your data, check your data. The recommended format is always to go with the SAP HANA development, as the name itself suggests, right? Development. We are actually creating your design time objects. However, in modular, we are just supposed to do your data preview, viewing your sequels, checking your data into the tables and views. Having said so, in a HANA modeler, even the business side, they have the privilege to create their views only. You're getting it right? So what happened? Let's say we have a business person who is little bit familiar with the native HANA, and they want to reuse your already created views so that they can just create a sample calculation view for their self in their schema. If you can see here in the catalog, we have different schemas. Okay, what is schema? Schemas are the functional grouping of different technical objects. Okay, for me also there'll be a separate schema. If you can see, Z HANA 0 for each and every ID being maintained on SAP HANA, user being maintained on SAP HANA, a personalized schema would be created for that person, for that ID. The reason being, whatever objects I'll be creating in my schema would not be visible to other person unless and until I will give a privilege to that particular ID. Okay, so let's say you have a business person who wants to create a calculation view just to see a data with the columns which he or she wants to see. So they have a privilege, they can create that view. It is not going to change the data. It is not going to hit the database in a way that it will manipulate the data. This is how the difference between your content, these two repositories, your modeler as well as development. In development, we do have a feature where we can write your procedures. You can change the data which is being present into any of the table by doing your inserts statement or update statements. Okay, then we also have another perspective which we use for your performance analysis, debugging your views and technical objects, and we also have a debug perspective as well. We'll discuss about them briefly in the later classes. We have BW also. Again, this will be touched for a very short duration because BW is not the scope of the class, but just to give an idea, we'll be discussing a bit about it. Okay, so we are going into development perspective only. Okay, so let's talk about these places. What is it? Catalog, as we discussed, catalog is the place where your schemas will be provided. In your schemas, your actual uh, design time objects will be written where your data will be stored, like your um, physical tables. All the tables will be provided in the schemas, and your procedures where we can do the manipulation into the data. All those will be provided under catalog. Content is nothing but the place where we can just do your data preview, as simple as that. Okay, your calculations views and analytical views, everything will be visible under here. Then you have your provisioning techniques. As the name itself suggests, provisioning means the way how the data can be inserted into your native HANA. So we have a SDI approach, as someone was asking, right? They want to know about SDI, Smart Data Access, how that been installed and how that been configured into SAP. So that will come under provisioning area. Okay, then security, each and every user which is been available into your SAP HANA database who has the access, this area is being basically handled by your basis people who give access and maintain the privilege within the SAP HANA. Okay, so these are the 4 places. We'll come into content. Okay, let's do this. Now see, the best practice is that you create and refresh each and every time whenever you create your design time object. This is your default repository. How you're supposed to open it? Drill down, and let's say we want to create under create a repository. Create a repository means that within your local SAP HANA system, you are going to give a place so that whatever design time objects you are creating will be stored into that place unless and until you will activate them. Okay, so this is the default place I'm giving in my seed repository. Just finish and the path will be provided. Now I scroll down and I want to create a new package. It's a simple view where we have just a projection node where we are using the table B11 mat. In this table we have 4 columns. Okay, all the columns have been used at the semantic layer. This is your semantic layer. In the semantic layer there was a concept about like what are the different. So we have different kind of places like numeric item, weight or volume, percentage. So that can be defined from the screen. Okay, here everything is key and this symbol is for attribute. Okay, so tomorrow I'll be letting you know how we can jump from one type to another type. Okay, and then in the property section, as you can see, data category, this is dimension, and we have a cube also. We have read about these two, right? Because we are not using the star join here, but today we can just see how to add the systems, what are the different perspective, and how typically a calculation view look like. The screen is that you have your left hand side, you will be having your different nodes. Aggregation, we have used projection because we are not supposed to have any numeric value here. If we had any numerical value, maybe your salary or your goods, how many has been, you know, sold out, those kind of a things, then we would have used our aggregation node. Then union, if we want to get the data from two different tables or views, then we would have used union. Join is to join the different tables together or views together. Rank is a functionality. We'll be discussing more and more about it in the later sessions. What is rank? What are the different types of rank and when we are using the rank, because ranks are very costly. When we use the ranks, the performance might decrease. So we need to understand when exactly we are supposed to use rank. But this is how it is. In the property section, we can see like this is a general projection. In projection, what is the table being used? So instead of checking, going again and again, like we are using it and we just want to click, we don't want to go further, we can check the details about that node right away into the property section. This is very useful when you have a huge calculation view with different nodes. Then just by clicking on each and every node we can check the full properties, because right now we have only used the input. However, there could be scenario that we have joins, then the about the joins also it will be visible what type of join is it, on which column the join has been provided. So properties, this section we usually keep like this only, just to get a quick idea when we are analyzing and building our calculation views. Okay, job logs, whenever you are going to activate your object, how to activate? Let's say you have made some changes, you want to save and validate. Okay, it's validating as of now. Validation has happened. Then you can check everything is successful. Okay, and this is how you can do it. And post that you can just, okay, there's nothing to activate actually, so I might need to make some changes. Let's say I remove this. Okay, now there is a change. You can see earlier this section was disabled, but as I have made the changes into the object, this got enabled, right? So this is how we can just activate. Click on it, it is activating the files. It's done. And there is a problem, the reason being in the reporting semantic layer there is a field being provided and it's not getting the value now. Okay, so this is the problem. So in similar way also, what you can do, change manager we can hide, in job logs we can go, we can check. Okay, the reason is there is no measures being defined, so this is the problem. So we need to do some calculation here, and this is how we need to do it. But yeah, these are the basic things we do whenever dealing with the calculation views. Any questions? So working with common design features, what are the common things we usually do while designing your objects? Okay, and then make sure you always read this. This will avoid any sort of copyrights issue. Okay, and then we have agenda. So basically in this, what we are going to discuss more is your, again, semantic node. Okay, then semantic attribute and measures. As I told you, in your this screen you can see all of them are attributes. This icon with the measures have a different icon which I'm not able to show you today. Okay, from here I can show. Yeah, so this is the attribute and this is the measure. Okay, whenever there is a numeric value, we will be changing. Sometimes system automatically make it as a measure, sometimes we have to give manually that okay, this column is nothing but a measure. Okay, then we can define it as a measure. Then we have some hidden columns concept, general properties of views, label columns and hidden attributes, sorting of data, which is very important because sometimes if the data is already sorted, then the data handling at the UI side become easier. Navigating to the source calculation view, overview of the possible nodes type. What are the different type of nodes available? Okay. Okay, as we have seen in the semantic node of any calculation view, it's automatically get created in the top. Okay, whenever, so if this is not there, once we create this projection node and semantic node connection, then automatically whatever there is a projection node will appear here in your semantic layer. Okay, it's an automatic process. If we want to make any changes, we need to go and change the properties, and we need to add hierarchies, input variables, and properties also we can change. Okay, if I'll make it as dimension now, then again I made it as measure, right? Automatically it is created as dimension. And if I will activate this now, it will be activated successfully, because with the cube it was expecting some measure to be there, but now it's not required. If we'll go to job logs, it is activated successfully. Right, with the cube properties we have seen, we are supposed to have a measures available in our semantic layer. Okay, then we have type of each column. Additionally, we can have semantic layer of each and every column. Then yeah, we can also define the meaning of each meaning of the columns, like we have the technical name, then next to it we can define your names as well. In the label column, okay, we can provide the name which will be used by the UI side also. So we can provide these are the name, and in label we can provide the correct name, which will be easier for the client also to understand. They are not the technical people, so from their point of view we can give the names. So when, like, we have two type, right, measures and attributes. So for measures, basically amount with the currency code, or quantity with the measures. This is how we usually define. Okay, apart from semantic layer, we have some other things being defined, like hidden columns, assigning a variable, assigning a description column to another column. So let's see that. Then this is how we can change name of each and everything. If you go here, this will be name, and then this will be the label which will be visible to the customers. And then here we can define our input output parameters. Give your name, label, which is a business friendly, attributes, hierarchy. If you have defined any, it will be populated here. Let's say I have these three, but I don't want this to be visible to my UI people. Okay, for my data only, I want it to be visible, like doing some data preview till projection. I don't want that this should be visible to my reporting application. In that case, what can I do? I can just check box this hidden column that okay, this will no longer be visible to the other applications. So in that way, this will be used. Assigning a variable, that will be input parameters and output parameters. I think this I all have covered. Okay, where we are just basically maintaining, okay, this is a which data category, type, standards or time. All these are viewed under this area. Okay, this is your dimension, definer access, invoker access. So in SAP HANA, we have two types of rights. Okay, definer is, let's say I am creating this technical object, right? So I am defining it. If I will make it as definer rights, so whosoever will try to view the data on top of it will be able to see the entire data. Nobody is restricted to see the data on top of it, because I can see, so anybody can see. However, from the security reason, I want only those people will be able to see data on top of it who are allowed to see the data. So who are allowed, that part will be handled by the security people, nothing but the basis team, where they will define, okay, who which person should have what kind of a role, and are they allowed to see the data or not, okay, under security. So for each and every user, some set of rules are defined on the, like on the basis of, okay, this is what they are supposed to see. On the basis of that only, invoker rights, who is trying to invoke this view, who is trying to access this view. So this is how it has been designed. Then type is, as we have discussed, it's a standard we have kept here. They could be time dependent also, as it is dimensional. So there is a default client which is nothing but your session client. We can also do a cross client. Cross client means that there is some sort of a data which is available in some other system. So if it's been designed with some those possibilities that okay, we can read data from another system, in that way cross client will be applicable, but mostly we do a session client only. Default schema, we can provide the schema name also, that where whenever anyone try to see the access, where exactly the SQL will be created, because for each and every data preview schema has to be selected. So for that case, we can provide the default schema. This is useful that you should provide. It will increase your performance also. Privileges. So from the developer point of view also, we can provide the privilege that okay, uh, uh, this view will be accessible to this schema people who all are have access to this particular schema. In that case, we can provide privilege from our side as well. Okay, it's a classical schema or SQL analytical schema. We have a section where we are going to describe with the hands-on exercise how to create analytical privilege and how to enable them into your calculation views. Okay, then we have column names, like okay, this is how it's been visible, this is it. Then okay, there is one another important thing with the performance point of view, that sometime it happens that the calculation views are taking huge amount of time for the processing, right? Then SAP has provided something called hints. Okay, if someone is familiar with the SAP ABAP, BW or any of the area, then they would be knowing that for SAP has given some sort of hints. Those are nothing but the names, okay, for specific kind of a situations. When we provide those hint as per the analysis why the time it's taking huge time, we can provide that and the performance can be increased. So they have provided a specific place altogether where we can provide the hints name. Okay, it's alphanumeric names, and then the performance would be increased. Okay, pruning configuration is again another topic where we are discussing related to optimization of the views, where we'll be letting you know how we can optimize the performance when there are multiple unions being used, then how the pruning can be done. So most of the part will be like in terms of performance will be comes under view properties. Types run with default client. Okay, this is done. Then privilege, default member, enable history, and all these are defined things. Hidden attributes, how we have done, right? Just mark it as this and it will be hidden, will no longer be visible to the front end. Okay, you can go through it, you will be able to recall everything. I have shown that already. Okay, so they are talking about the navigation, basically how to check the lineage functionality, what is being used where. I don't think my right click is working. So what happened, as you can see in this screenshot, right? I'll increase the size a bit. You have a view where you want to check, okay, this gross amount being calculated or being first used from which node. So what we can do, we can just click on the right side, right click. Okay, there'll be option which will come as show lineage. Okay, with the help of show lineage, a arrow kind of thing will appear. Everything is graphically connected, right? So the path which is connected and have the value, it will be colored, it the color of that path will be changed. You will be able to understand, okay, this gross amount is coming from SAP ERP data node. Okay, if you want to go further, then you will go, if it's not direct table, it's another view or maybe procedure or table function being consumed, then you need to open that and then you can navigate further. Okay, so they have a feature provided in calculation view which help in navigating for any of the column. The projections are projection, aggregate, joins, unions, then star joins, rank. Okay, these are the nodes we have available. Then in the possible nodes, what all values can come? It can come as a table functions or your direct tables. We can have hierarchy functions also. Okay, then we can have a graph uh, for a dedicated algorithms. Yeah, so this is pretty much it. Like on a normal basis, on a day-to-day task, whenever a business requirements comes up, we are supposed to have knowledge about the types of calculation view, which is two types of calculation view, cube and your dimension. Okay, when we are dealing with the dimensions, then we are supposed to have only attributes, no measures. With the cube, measure is important. Okay, and then different kind of nodes, we have your union, joins, star schemas, projections, aggregations. So these are the different rank, different nodes which we can be used as per the business requirement. On the analytical side, on the property side, in the semantic section, we have the features to select even while designing itself. Let's say we have selected earlier dimension but we want to make it as cube, so we can do it, nothing to be worried about. So most of the things can be handled from here also if we have selected a, if you want to make any changes in terms of properties. Okay, input and hierarchies will be explained later on. Okay, so all of you will be able to see something like this once the access will be provided. I believe by now you should have access. Mail must have been circulated. Each and every module you will be able to see, and today we have covered these three modules. Okay, in this theme I'm not covering further today because unless and until all of you just have, make sure that you are able to add SAP HANA system. This is very important before we start tomorrow's class, so that once the activity is done, I will give some 10 minutes or so, 10-15 minutes, so that you can all do those simple things right away in your system. Once the class is over, you will be able to do the lab activities which will be provided. So today what you can do, you can just try to check if you are able to access SAP HANA system, you are able to add system details into it, and then you are able to open the perspectives. These are the three things which we should be able to do by today. And calculation views, what are the different type of calculation views, and are you able to create a simple calculation view with the table already available in the system. Today we are going to discuss about the joins. Okay, what kind of joins do we have, and when do we use them? Yeah, you will be dealing with your nodes like union, where you need to combine data of different uh, areas, and you not need only the similar columns, you would be needing different columns as well, right? So for these kind of a scenarios, we'll be working with union nodes as well. And there has been scenarios where we are supposed to create union with the constant values, that okay, with each and every records a constant value should appear. For that cases we can create a column as per our need. And what is the main difference between union and union all? Okay, these kind of things are going to be discussed.
Hey there! Want to master SAP Native HANA? Our course is here for you. Take it at your own pace on our platform. In this course, you'll dive deep into SAP Native HANA. It's like a toolbox for managing data, from organizing supplies to streamlining operations. Our course covers it all, from basics to advanced techniques, crafted by seasoned experts who know their stuff. Your teachers are pros with years of experience. They're here to guide you and tackle any queries you have. And guess what? Our students love it. Folks just like you have found our course incredibly useful. The best part? It's budget friendly. You get top-notch learning without breaking the bank. Ready to become a SAP Native HANA Pro? Sign up now. For more info, head to ZaranTech's website. Alright, let's test your knowledge. Here's a question for you. What does SAP Native HANA primarily focus on? Option A, data storage. Option B, data processing. Option C, data visualization. Option D, data encryption. Take a moment to think, and when you're ready, choose the correct option. Remember, each choice holds a key to unlocking the answer. Good luck. Type the correct answer in the comment section.
Basically in projection node, as we discussed yesterday, projection nodes are mainly used for your dimension attributes. Okay, we are not supposed to have any aggregation provided there. So the calculated columns, again, there is a concept of calculated columns. Those will always be aggregated once calculated column will always be executed once the aggregation has happened. Okay, let's say that you have again employee data. Okay, let's take example of this employee data. In this employee data, you want to do some sort of calculation talks of your annual salary. Okay, on your annual salary, if you are doing some calculations, that will happen once your different sort of aggregation will happen, let's say on the basis of your date, that on what date we want to group your records, and then we want to see, okay, for that particular set of days, how many people were hired and what was their average annual salary, like that. Okay, and also let's say there is a scenario we want to see how many people are getting um, we are aggregating how many people are getting the bonus more than 15% or maybe less than 15%. In this kind of a scenario, a calculated column will be provided once the aggregation is done. It is an important thing to be understand, because sometimes what happens, we create calculated columns, we expect them to work in a certain way, but they doesn't. The reason being, there might be some aggregation happening. Different type of join. So as we said, inner join, left outer join, right, full, referential, text, temporal, and spatial. There is another one more type of join, which is self join. Okay, so inner join is you might be aware of it, right? So inner join is that, okay, you want to fetch those records only which are intersecting, okay, where the records are available in both the tables, then only those records will be picked up. Let's say you have table A and B. In table A, you have 2 columns. In table B, you have 3 columns. In your output, you want both the records from your left table. However, from right table you want only one column, right? So in that case, only those records will be fetched where the join conditions are matching in both the tables. It's not like all the tables from your left will be there, and then for the right columns there'll be null values. Okay, so inner only work when you have matched condition at the both side. Left outer join, it's the other case where you will be picked up everything what you have from your left table. If that value doesn't belong to your right table, there'll be null available, but it will not skip those records which are not available in both the tables. Right is just a similar thing, it's just we are going to pick everything from the right table. Full outer is that irrespective of if all the posted facts and all the dimensions will be encountered here, and then combine the effect of left and right outer join together, whatever is available in left and right, and that will be visible. Referential join is something which is basically like a inner join, but here what we do, we make sure that integrity is maintained. What do we mean by that? For each and every value available on your left side has to available on your right side. Okay, then only referential table will work. So what happened, let's say we are going with the referential join, and we are not sure about our data. If for each and every value, okay, let me try to draw it. What happened, for each and every value available on your left hand side, there will always be one value available with that on your right hand side. Okay, this is what is basically referential join. We'll cover this into lab as well, but again this is one of the important join to improve your performance. Text join are nothing but basically used when you are dealing with your um, languages kind of a column, where we know that okay, for specific, let's say when someone provided a value en, okay, then the entire UI should be changed as per the language we have selected. En is related to English. Let's say it has been mapped that whenever n1e is selecting en, it should map your source data, that okay, English language, all the content should be changed to English language, and similarly all the languages should be mapped with your master data. So for those kind of a scenario, we use text join. Temporal joins are typically used when let's say you want to show a report and you have provided your start and end limit. Okay, in that case, only those data, instead of using your input parameters and input parameters, that like two columns need to be created with the input parameters, right? Instead of that, to limit your data at the source side itself, we have a concept with the temporal join where we can create a dynamic condition also, that dynamic condition as in that current date plus one, like that. So for example, today current date is 1st of December. We want that the data which will be shown will always be current date till 30, like the entire month data. So instead of giving this from the front end side and then reducing your data, we can provide the filter in your temporal join itself with the dynamic condition, that okay, only that kind of a limit should be visible. So for those things we use temporal join. Spatial is basically to have some region kind of information. When you want, okay, the data should be visible when we are in specific region, so it should be visible to that region. So for those cases we use this. All these are important, and most of important thing is with the self join. Self join is a condition where you need to handle only one table, and with the one table you want calculation on that table itself and then generate some other columns. Okay, in that case we are going to, there is, the join is provided on the same table. It's not like we have one, let's say we have an employee table, we are going to create two nodes, both will have the same source, that is employee table, and then on the basis of specific conditions for which table we want to, for what kind of a join condition we want to use among the same table, we will do that, and then we'll generate the values out of it. Okay, usually we do it in the case of aggregation, that we want aggregation in the one table, and from the second table we want some values. For example, let's say you have HR data. In HR data, you want to pick up data for a employee in a specific department, and you want to do the aggregation. Okay, and then from the second node, what you are doing, you are joining on the basis of, let's say, ID of that employee, and you are doing the you are getting the aggregated data. This can happen. Yeah, some of you may say that aggregation can happen with the simple SQL also, but the scenario would be little different. Okay, self join will help, and we usually don't prefer self join because those are time consuming, but there could be scenarios that we have to use them. Yeah, text join is again has been provided with the example that we are providing text join. Join direction is from left to right, and the preferred column is your language column. Okay, and this is it's very important to maintain cardinality if you know it's one to one, because that will save your time. Because once system know, okay, the record has been found, it will go to the next column to find its next value, to search where it belongs to. It will not go further to check the same value in your right hand side, right? So cardinality is very important. Temporal join, again the same thing, like we have, let's say, a date. Okay, with the date we are trying to give customer status in the two columns, that when it is starting and when it is ending. In this case, we are going to provide these values from the front end side, from the top view of the semantic, that okay, those values should be populated where date falls under this range. However, we can create a dynamic arrangement also here. Star join we have covered quite couple of time, where the fact master data or dimension views will be covered here, and we can have n number of views joins conditions, and we can join them with your star join. Multi-join is somewhere again the same thing, that you have like different datas, and then there is a capability that you can join one table with the number of tables, like here order ID and then product ID also you are joining with another thing. So this is called multi-level joining. Okay, multi-joins. Union nodes, let's say, yeah, another thing I would like to explain is that unions, when do we use unions, right? Usually unions are used in the finance domain mostly, or when you are getting data from different sources of same type. When I say same type, let's say you have a survey data. Okay, and a survey could be, we are receiving survey from a different kind of systems, right? Let's say we have a service now also, from where we can receive data, like whenever we do any shopping on Amazon, right? Then typically they ask us rate the product, rate the quality of the product, these kind of a questions. These are nothing but your survey questions, so we can receive from there, and then we can have survey from the team who are preparing the product. They can also rate what was their overall experience. Do you think the quality is up to the mark? So in that way, each and every different team, the consumer team, developer team, and even the finance team, everyone is rating the same product, but from different set of questions. And in similar way, we may have receiving the data from different systems. So in these kind of a scenarios, what usually happen is the column names are different. Okay, the content could be same, the column names are different, and then the formats are different, and sometimes the response are not same, that okay, we can join them together. Even the column name is same, the it will not possible to do a join operation on top of them, because the response is entirely different, right? So in those cases, what we do, we keep the same column name, we try to keep the same column name, and then we just merge it, so that we can get all sort of responses has been received irrespective of their formats. When I say irrespective of their format, means it could be alphanumeric for a response, it could be complete numeric response, 1 2 3 4 5. So all can be clubbed together, and then we can use different kind of features, like your data cleaning, and those things can happen later on. So union is very one of the important thing, but again it is time consuming and it may degrade your performance. So we try to understand how optimized way we should be using a union. Okay, in this example what they are doing a forecasting, I believe, where the actuals and plans has been the two nodes. In this case, how we can do the optimization is with the help of a pruning table. There is a concept which we'll be discussing further in your curriculum. Also you can check that if there is a topic for the table prunings, union pruning. So with there we will be doing a lab activity. Standard unions are nothing but just like giving your simple union operation, how we do either union all or you just want the distinct value. Okay, these type of unions has been provided here. So let's say they have a calculation view where these values are available. 2 times 1000 is there, then 2000 here, 2000 two times, and yeah, then they are doing a standard union. So what is happening, all the 6 records are getting inserted here. Okay, and then result after the aggregation is that you have only a distinct value. Okay, so this is how it has been shown that at the standard view, it's standard view is not standard union is nothing but your union all. Okay, and then aggregation level only your distinct value will be visible. And because it okay, it's important to understand your data. Sometime when we are deal with the numeric value, we might convert them while doing your union as this as a attribute instead of measure, because we don't want them to aggregate and sum it up when we are previewing your data. Okay, so in this case the aggregation is happening, and as you can see 2000 is becoming 4000, right? So that's if user is expecting that it should be visible as a how the data was at the rows row level, then we should be maintaining the same kind of we need to make change the data type of your quantity kind of a column, quantity, amount, these kind of a columns. Okay, it's a common problem which we encounter most of the time, that okay image it's coming double the value what we are expecting at the measure level. So the point is, go and check your view, check if there is any union being used. If it is, make sure your amount the measures quantity are being treated as attributes, and later on you can change them, no doubt, but it is important at the union level you make them as attribute. Okay, again then there is a scenario that we want to join we want to union two different set of data. Okay, so instead of providing null, what basically we are doing is we are providing a condition. Okay, what happened, as I said, when we do the union all, sometimes we may not have the value of a particular column, right? So in that case, instead of providing null, we are giving a constant value here. As it's a amount, instead of giving any other value, we are giving zeros, so that at the time of aggregation, at the time of final view, we should not be having any trouble. What happened, uh, when we deal with the operation like average or divisions, in these kind of a scenarios, if you have null value in your source data, that could create problems. Okay, to avoid those scenarios, it's better to use zero instead of null. Okay, they have given the scenario when to use join and when not, which I already discussed. Basically you should use join when you know, okay, you are you need to combine measures which are coming from one or the other tables or calculations view. You typically create joins. But in other scenarios, when you know that okay, you have address your join would be very costly, right? In those scenarios, just to do the calculations, we go with the union scenarios, we don't use joins. There they are giving an example of union and union distinct. Union distinct is nothing but unique values, okay, out of your join. Okay, what is the difference between union and union distinct? So let's say you have one person who have provided survey multiple times with the same response, okay, coming from one system, and then the same person has given or maybe the other, like in that case what is happening, your same row is being inserted into the data which is not making any sense or insight out of it. What we do, we use the union distinct, okay. And when we know, okay, only unique records are there and we want all of it, that time we use union all. So remove your duplicate records, we use union distinct. To have all sort of data, union all is being used. Here what we have used, what we call to this method, this is nothing but your CDS table type, CDS table artifacts, okay. Core data, this is one of the good URL which you can access, okay, for doing your core data services table creations, and even for other things also. You may get some examples. So for your daily basis, if you, let's say, want to recall anything and want to check, you can check this URL, it will help you. Okay, so for core data services table artifacts, we can use this kind of table, HDB DT tables. How do we create them? We go to new, go to others, then we check a folder available with the name SAP HANA. Under SAP HANA, you will be able to see something called database development. Under database development, you will be seeing different sort of technical objects, which the syntax and the process how we should create them. So we can create a simple database table. We can create DLL source file. DLL source files is nothing but your CDS tables, flow graphs, and if we are interacting with some other systems, so we can do everything from here only. All the artifacts which are physical in nature, as in where we are actually going to store or doing your DML operations, everything will be available from your database development. Okay, so this has been created with this process. Once we do it, we provide our name, let's say sample, just click next. Then there are different sort of entities which we can use. We usually try with the first only, empty context. This default values will be provided. Once this is provided, what we need to do, we need to define the entity. Okay, entity is nothing. Let's say you have a functional area of employee. Under employee, you want 4 different kind of tables, 4 different kind of entities. Okay, then you say salary. You can say salary and let's say personal information, where we can provide the address on those kind of details, PI basically. So in same way, what we are going to do, we are going to give the same namespace, same schema, under same context, only the entity name would vary. Instead of creating this file multiple times, we can create one file having a different entities. Okay, let me open this employee table. As you can see what I did, everything is same, just your context is different. Then you have single entity with the name employee, where name, title, department, business, gender, all those information are provided. I can create one more entity here, let's say with the name address, where I will provide address informations along with or maybe a PI, personal information, where address, phone number, those kind of things can be provided, right? So this will save the development effort and easy to access whenever any new enhancement or those kind of things are comes out. Another point here is that make sure whenever any new column is being introduced, you always add after your last row is updated. Sometimes what happen, user give the requirement that they want the new column should be there in between. So just in that case, what we need to do, we need to drop the entire table, and before dropping we need to take the backup. Usually we always inform to the business that this is not possible because it has been designed, we'll give the column this way, and then during the view creation in the view side we handle those scenarios. Okay, because creation and dropping of the table is not recommended, right? So each and every time, if let's say what you did, you have added your new column here in your source file, design time file, you will be able to see your actually placing it here. But when you see your data under your schema, let's say I'm doing a data preview here, trying to check the definition, the column will be created only after row this. Let's do this activity right away. Let's say I am creating a new column with the name, see, it's been created here. So what will happen in this case, there is a discrepancies among how the structure is visible and how you have created in your source file. So it's always a error thing. We should not do this way. Okay, sample table. Yeah. So in this way, just with a single statement, we can do it for a temporary purpose. Let's say you are when do we use these kind of scenarios? You have a procedure which is running in production, and you need to optimize the data, and some recovery procedure need to be executed. In those kind of scenarios, what we do before running the recovery procedures, before running deleting data or maybe doing any manipulation in the production, we always take a backup. So in those kind of exercise, it's always recommended to create a sample or maybe recovery tables where entirely data will be stored. How is it? And you can just use the keyword with data. Yeah. So these are the type of table creations which we can do. And maybe today what you can try creating these attributes, these fact tables, because these are the practice which we follow for creation of your tables, and moving it into different environment is easier because these can be uh, captured into a transport request. Okay, so I hope you are aware of transport request process. So transport request process is nothing but after the development work, you are supposed to move it into different higher landscapes, right? So during that time, you can just, it's easier to capture these. Otherwise, you are supposed to provide the entire sequels and keep them handy whenever you are supposed to move them into production. So that is not recommended. Now what we are going to discuss, persistence layer. As we know, SAP HANA is in-memory design, in-memory database. It doesn't mean that we are not storing data anywhere. We are. And once it is in main layer, after that also, after a certain period of time, it is going to your storage as well. So persistence layer is something from where we actually access our data that much frequently, and persistence layer is nothing but it's a layer where which is available in your memory, where we are storing your data. Then loading data into tables, hopefully we are going to do this lab activity tomorrow. Then we are uploading the data into tables with the help of flat files, and we are also going to discuss about remote data, accessing your remote data tables. What that is nothing but your virtual tables. And we'll be covering a bit about the SLT. Okay, I'll give you some other reference links for SLT because I understand people wants to know about it. You can ask me your real-time challenges also, because some of you are working, right? So if you have faced recently any challenge, you can just let me know that. Okay, let's start. What is persistence layer? Basically, persistence layer is nothing but the layer where data is getting stored. Okay, this layer sits very bottom in your landscape. It's a lower most bottom layer, and consumption at the top contains application accessing virtual layers. So basically all virtual layers are nothing but your views, right? Because in views we are not actually physically storing the data, we are just accessing virtually. So consumption of these tables are done, and those are being consumed excessively by virtual layers. Modeling wise, if we see, This is a consumption layer, which is your we can say apps. Then we have virtual layer, which is nothing but your models, right? Calculation models. Then you have your persistence layer, which is nothing but your physical tables. Okay, this is how it has been designed. Then methods, how we can actually store data into our persistence layer. As we have discussed, there is something with the flat file update. In custom apps like with the SAP 2.0, there is a concept of XSA. Okay, in XSA we are storing the data with the help of table artifacts. What is our artifacts? That is nothing but your CDS views. Okay, CDS table creations, all those things comes under custom apps. Then we create SAP HANA artifacts on top of it. Another thing is ETL tools. ETL tool is like, let's say you have bots, if you have heard about it, SAP bots, which with help of bots, what we do, we are fetching your data from one system. It could be SAP or non-SAP system, and we are inserting those records into your tables which has been created in SAP HANA, and we are inserting your data. Then we do have a direct installation of SAP system itself. Let's say we have SAP S4 HANA, and then we are generating tables directly with the help of that, and we are storing our data. Okay, so these are the typical methods. Yeah, so they have given the example of data services, bots, and modeler. We are not directly supposed to create the layer. We are just supposed to create the tables on top of it. Okay, as a developer, our main focus is afterward is on the virtual layer where the creation of calculation view happens. Okay, so basically they are letting us know the type of tables, what kind of a tables we can create. Column based tables, row based tables. As we discussed yesterday, we create a column based table when we have to do a frequent fetch from the system. Like whenever there is a reporting being used on top of your tables, we are going to create column based tables when we need to insert data, and after that we are, maybe let's say we are inserting that data into some other tables. Okay, we want that the insert operation should happen fast. In that case, row will be used. And then we also have a concept of virtual table where we are not inserting the data directly into our SAP HANA. We are not consuming the memory for data insertion. However, we are just fetching it, just the view operation is been done. Then the two kind of approach for the creation of your table. So the first thing is when we are dealing with SAP HANA 2.0 and above, there is a concept of Web ID SQL consoles. That lab part is yet to be shown to you, because that will be available by next week or so. So Web ID is a new concept where instead of creating your artifacts from HANA Studio, we create directly from Web ID, and those are easy to consume in your UI applications. Like let's suppose we have 4 application, then we have let's say we want to create a business want us to create an application which is not supported by SAP. It's a UI which has been, let's say, created by help of Node.js and then other technologies like big data, and those kind of things are required, right? In this case, what we do, we use the Web ID concept because interaction among the different technologies are easy, like Python and all those things. It's easier if we do our calculation from here. It's user friendly. Then we can we create execute, and then we create the source file. Okay, we build with the Web ID. How we are doing in the SAP HANA Studio is we are creating, it is getting stored in repository, then we are activating, right? Similarly, the operation to activation is nothing but the build. This is the difference. Once it has been built, nothing but the activation, then it will be created into your SAP HANA persistence layer. This is another way how we are doing it now, where we are writing our SQLs. We prepare the schema. What is the schema? Then we prepare the elements like creation of table, table type, table elements, columns, and anything if we want it to be designed as primary. So these kind of things been set in the HANA Studio. Okay, once we have the tables,
Hey there! Want to master SAP Native HANA? Our course is here for you. Take it at your own pace on our platform. In this course, you'll dive deep into SAP Native HANA. It's like a toolbox for managing data, from organizing supplies to streamlining operations. Our course covers it all, from basics to advanced techniques, crafted by seasoned experts who know their stuff. Your teachers are pros with years of experience. They're here to guide you and tackle any queries you have. And guess what? Our students love it. Folks just like you have found our course incredibly useful. The best part? It's budget friendly. You get top-notch learning without breaking the bank. Ready to become a SAP Native HANA Pro? Sign up now. For more info, head to ZaranTech's website.
we can also create our tables with the help of source files. Okay, when do we say source file? It's like how we are doing it. Let's say you have a CSV file, you have literally your text already, okay, and then you want to create the similar into your HANA Studio. For that, what we can do, we can just check, okay, this is a source file, and then we will directly deploy it, or directly call it into the HANA Studio or web ID. Okay, that can also be happen. Let's say your colleague, okay, that person has already created a table in his personal schema, and now we are the testing has been done, and that person says, okay, let's do one thing, I will share the CSV file with you, you can go ahead and create a table with the help of that. In that case, what we'll do, we'll just copy in a local system where we have HANA Studio, then fetch that table and create a fetch that file and create a table right away with the one clicker. We don't need to do that activity again. Then this is the way we have done it now with the CDS artifact. We have created we went to SAP HANA, then we saw the tools and we created the table, right? This is that approach. After creation of table, we are supposed to insert data into it. So the typical way how we usually do with any database is using your insert queries. Okay. After that, we have another way, which is loading data with the help of source file. So what happened? We have a table. Okay. In that table, we just right click and say import data. And even we have something called export data. So import data is, we have a CSV or Excel sheet, and which has headers and some sample data. This approach we are going to use with the employee table. Okay, with the employee table, we will just select maybe 20 records and we'll copy them into your local system, and then we'll import them. Okay, so just click on import data, give your location from where you want to fetch that file. Then the second thing which will appear is, okay, what is the table name? Then we'll say that is like we select a table name, and it asks couple of questions. It asks like, does your source file has columns? If it is, then the data will start reading from the second row. If it doesn't have a columns, it start reading from the first row. So those kind of settings we have to do, and then one-to-one mapping can happen. They one by one, the steps has been provided. Once you start a lab activity, we can do that. Data from under your SAP HANA content, you have data from local file. Then you can give the path to that local file after browsing, and you can, okay, I think this is for export. Then you provide, okay, the header to the row is existing, which is in line number 1. Then import all data starting from line number 2. Okay, then you also provide, let's say it's a CSV file, right? So what is a common delimiter? So it's a comma is a delimiter. So these are the specific properties basically what we define. And then sometime you may see these kind of colors coding. Whenever it's clear gray or black, it is fine. It's one-to-one mapping, there is no issue. With this, you can see like one information being provided that we are trying to map n-var char with a decimal. That might cause some data issue. Okay, so it is up to us. If we are familiar with the data, we know that this will not create a problem, we are good. Otherwise, what we'll do, we'll try to change any of the file, either the target table or the source file. If we know that okay, source file can be modified, we will do that. Otherwise, target table has to be modified. Yeah, so there is something called start or OK. We click on that. After that, job log window will appear and it will let us know if it is completed successfully or unsuccessfully. This is how we can store our data. We can do a data preview on top of it. Then the virtual tables. There is a provisioning tab, right? For each and every user, we can see for which user we have a table available. If it is a HANA to HANA mapping, let's say there is a real-time scenario where you want to copy some production data into your development for some testing reason. What you can quickly do, instead of getting into different teams and asking them for data, you can create a SDI connection by yourself. Okay, what you need to do for that, you need to know the host name details and the user and ID, ID and password for that system. You need to go into your provisioning and create a SDI connection. While creating your SDI connection, in the top level there are some set of drop down list. In that drop down list, yeah, so we go to provisioning. Okay, under provisioning we have something called remote resource. Here in the remote resource, basically we'll right click, okay, and then create new. In that case, what we need to provide, we need to provide the host name. You can provide any source name, right? And adapter, this is what. So currently they are fetching the data from a Oracle database. That's why Oracle log reader has been used. However, if we are doing it among SAP HANA systems, then there is something called HANA with the name SAP HANA. So we can use that adapter. Provide host name, port name, and your ID and password, and then we are good to get that connection. Okay, what will happen then once this has been created? From this arrow button, you can see all list of schemas available in that source. You can go to the specific schema which you want to access. You got your table, then right click on your table and just say create a virtual table. There will be option in the drop down list. Let's see if they have provided. Yeah, so we just we go there, we click on right click, add as a virtual table. Okay, once it has been clicked, it will ask the location where you want to create. Okay, then in that case you need to provide the location, and once it has been created, you will be able to see in your system. Okay, one important thing here, you will be asking in which system we need to create this connection, right? So you need to create this connection where you want to access that table. So you want to access production data into development, so you will be creating this SDI connection in development system under provisioning. Okay, once you create on add as a virtual table, that virtual table will appear in your catalog, just like how you create another physical tables. So once you have your table created, you can access them remotely. In this case, you are not actually using your physical memory. With virtual table, the main challenge is the performance, because we are fetching from the another system. So it's always important that your other system is up and running. There is no latency because real time we are trying to access. And the drawback is, if you want to write anything in this physical table with the help of virtual table, that is not possible. It is possible if while defining your SDI connection, you are making it read and write, okay, which is not recommended. So the virtual table is only being used when you want very limited amount of data to be fetched from your virtual tables, and yeah, performance is up to the mark. With that, we have covered two type of ETL approach, flat file as well as SDI. I'll try to cover a little bit about Okay, so what is SLT? What are the different kind of challenges we faced with SLT? How to define SLT server? So SLT is SAP Landscape Transformation, which is again a SAP tool for ETL. Nowadays, we use SLT quite often. The reason being it's real time. There is almost zero latency between source and destination. And even if we define SLT server, we do SLT operation, we always create jobs which keep on checking if HANA side and the source sides record counts are matching or not. It's a typical activity in each and every project we should do. Okay, instead of getting some surprises and instant trace from the business side, it's recommended to create your procedures, access jobs or anything which will keep on checking your record count at both the sides. How we create SLT server? So SLT tables. Let's say we have a SAP. Another thing is that we have SAP source. Okay, with the SAP SLT, we need to have ECC on these kind of things only. Then SAP will have a best performance. We'll be having a source system and then SLT server. SLT server is a middle layer to create a connection between HANA and SAP source system. Okay, on a daily basis, you will be doing your monitoring with the help of SLT server. In SLT server, you have a typical transaction like LTR, SLTR. Okay, these are the transactions which you use to monitor your server. What kind of features are available? So in terms of features, let's say you have a table which is huge in data, and you want, while loading the data from source to destination, only specific records should go. So the filter can be provided in your SLT server on the source tables, which will define only these records should go depending upon the condition, which is a plus point. Then it's a real time. The only drawback is whatever data you have in the source side, you are creating similar data at destination also, which was in this case the redundancy is happening. You are consuming, you are paying for the same records being stored at two locations, right? So in that case, it's a drawback. However, in terms of real time fetching data, it's a plus thing to have. Okay. And someone asked yesterday about the delta merge. When we come into SAP HANA, we know that the real-time replication is happening. Okay, and memory is getting consumed at HANA side also. Once automatically by the SAP HANA system, at a certain period of time, refresh is happening and merge operation is happening. What is the help of merge operation? That whatever data we have received from the source side, that is getting inserted into your main storage. So this is happening frequently. Okay, but sometime it happens that it may take certain time. We are receiving huge amount of data and it's creating a problem in terms of main memory. So what we do, we manually go, we go to the table, SLT tables, we right click and we perform the delta merge operation. So delta merge operation is whatever are the new records, those will be stored in your storage. Okay, this is the main difference, that why do we need delta operation? Because delta merge is required whenever you are having a space crunches most of the time. What we are going to do here is what do we basically mean by filter operations, and what are the different criteria we can create our filters. Then comparing filters and the where clauses, filter operation in calculation views, client dependent views, filters using domain fixed values, restricted domain fixed values using text joins. The filter, as name itself suggests, we are going to limit our data, right? Let's say you have a report which has been consumed all over the at a global level, but for one specific region it should be filtered for that region, right? In that case, what we can do, we can provide the some business person, they don't want to see the entire global data. They are more concerned about certain products, certain categories in their region. So in that case, filters are very important. In that case, we can give specific data to them. The flexibility under the filters. So we can provide hard-coded filters that, okay, let's say you have 7 categories in your product. Out of that, we just need to show 4 categories. So in that case, we can provide a static filter there. However, there could be scenario that those like we want the report should have global idea, okay, but whenever anyone is accessing in a specific region, they can provide that filter. So in that case, it will be flexible filter that they are providing on dynamic basis. How does filter work? So this is the main thing. Most of the time we get confused with the thing that what is the difference between filter and where clauses. With the filters, these are nothing but your design timetable artifacts. Okay. However, your where clause, it is defined during the runtime. Okay, we are good with the runtime and design time, right? So design time is like we are doing it in your repositories, we are activating them. So these are prepared. We are not supposed to do anything afterward. However, your where clause, those are done when you are running the query. And then the another thing is applies to the data before the query start. However, the where clause, these are applied when you actually running the query, again during the runtime. Usually what happened, where clause are a bit slower than the filter operations, because as the result set is reduced before proceeding your query itself, right? So what happened, how the functionality of where clause happens is you are fetching your entire data and then you are providing filter. However, what happened with the filter, you provide filter first, you already limit your data and then execute. On top of it, you can again provide a filter, right, with the where clause. So this is the difference between filters and where clauses. Where all we can provide filters, we can provide at the projection node directly. We can also provide at union, rank, aggregation, and star joins. Okay. But what is the best practice? Best practice is always provide at the projection level. Why to take your data till the node where it's already been at the mid layer, right? So always provide maximum at the projection layer. But let's say you are doing some union and then you are expecting to get certain kind of a data, you can provide there as well. We do have a feature. Okay, so sometime what happen, we have different clients, right? 200, 100, 500. These are the typical SAP specific clients. In these clients, when we are reading data from source file, usually we have a column with the name client, okay, where we define, okay, from which client we are supposed to get the data. In this case, the filters are client dependents. Let's read it out. The clients, sometimes also called SAP client to avoid any confusion with the concept of customers, it is general concept in SAP systems such as SAP Business Suites and SAP Business Warehouse, right? That's what. So in a business warehouse, we usually see 100, 500, 200, these kind of a client systems. And if you are aware of the SAP Business House, 100 client and 300 client. 100 client is something where we actually create our artifacts, we actually create our objects, and we store master data. In 300, we usually try to access the technical objects which we have created, and then we do our data checks and those things with the client 300. So 300 is something where we actually expect our data will be inserted in the production, 300 or 500s, right? It is like any number could be there, but the general practice is these two. In this case, it is very important to isolate which client or other field which has been practiced and used by SAP is mandate. Okay, so we define this mandate. What is the value? And it's a German word. So we define, okay, what should be used. It's typically 3 value, as I said, 200, 300, 800, like that. In your production node only, in the mapping, you can provide data source, and there you can define the properties. Client column is mandate. Okay, or your client, or it could vary the column name. Usually in SAP world, this is a column name. And then you just provide it's a session client, and you provide the session client number, 3 digit, and then we are good to go. What we are doing here, basically, we are always defining within the SAP HANA, out of 4 different clients, we just want to read data from client number 800. So as we have discussed, right, in the semantic layer, we have something called cross client, fake client, and session clients. So cross client is irregarding of the client number, the full all sort of data will be fetched, because the table names and all those things are going to be same. So it will fetch data from all the clients. Session clients will be provide the session itself, the client number, and it should be good. Fixed client will be providing the number. Session client is like dynamically it will be provided, and then that user will be accessed accordingly. So fix is something where we hard coded the value. Session client is that dynamically system will figure out, okay, it belongs to which system. What we are doing, we are just defining that, okay, in order to restrict our data, let's say with the text joins, we are defining the cardinality 1, and we are giving the language columns defined as this column, right? So we basically do filter that, okay, we have this column on which you always have to check. And what is a cardinality? 1 is match. It's nothing but the concept of a text join only. With the help of text join, they are just letting us know how we can filter the data. I have prepared example. With this, we will try to cover all the join conditions: inner join, left outer, what will be the output. Okay, let's see. These are your 2 tables. Okay, I want maximum participation. These are your 2 tables. One is your transactional table. Okay, one is your master data. In master data, you have 2 customers. They are into Bangalore and Hyderabad. They were staying in Bangalore from so and so duration, and in Hyderabad from so and so duration. Then you have your transactional data, where only customer 1 is present with 2 IDs. Okay, and customer 1 typically sell, okay, let's say purchase something of 1200 in on specific date, 800 on specific date. Now if we say let's say master data is your left table and this is your right table. Okay, in the case of left outer, okay, let's say now you have a scenario where you need to understand which table which customer has purchased during this time. Okay, so this condition has to fulfill, like C1, let's say C1 has purchased, because only C1 customer has purchased, right? C1 has purchased, the duration should match with what has been provided in the journey. Okay, in this case the journey is within 2022 year only. Okay, they have purchased in 23 also, but we doesn't want that. So how we are going to do it? I'm just interested when the customer, because it's like, let's say you have a credit card. Okay, not a credit card, like a special bonus card from lifestyle. From lifestyle you have some purchase some card, where whenever you make a you do a purchasing during the time you have contract, you will be provided extra points which you can redeem. Okay, in that case what happened, the business is only want to know when person has purchased during the tenure when they were under the contract. Okay, if they have made any payment after that, that is okay, that's like a normal person who doesn't have the contract. Okay, so in that case, how you will handle this business scenario, that only those purchases should be reflected, so that they can change it to like points, maybe 4x points or stuff like that. From the performance point of view, you have said the right thing, we can use the filters also, but now it make the difference how temporal join will increase your performance. Okay, so this can be done with the two ways. One you have discussed, another is temporal join. Okay, so once you will be doing with the help of filters, okay, what will happen, you have to give the join condition, correct? What join you will use first, because we have to merge two tables, we want some specific columns which are not available in the one table itself, we need master join is required, correct? Yeah, so we'll take help of any first join condition. Let's say we take help of inner join only. Okay, then we'll get the set which we discussed just now, right? We'll get those two rows, and that is okay. Then we will provide the filters, or do you want to provide filters first and then do the joins? So maybe this you can take it as an activity. Okay, maybe you can create these two small tables or any similar tables, do this activity with your filters condition as you're discussing, or do it with temporal join. What will happen with the temporal join, you will basically give a join condition on the customer. Okay, and then you will select the date. From transactional table you will select date, and in the left table you will have your to range for it. Okay, in that to range you will give this valid condition, valid from and valid to. Check the performance. You are not supposed to do, you are first thing, you are not doing two operations here, you are optimizing your view in terms of uh, filters. Basically filters are being dynamically applied here, even the customer doesn't have to do anything here, they don't need to give any values to write, correct? Because with the input parameter what will happen, um, system will give, and then it will entirely first at the first place how input parameters are worked. Yesterday we discussed, right? First, at the projection node everything will be read at least from the HANA side, and then the input parameter will come into picture. But in this case, while reading the data from HANA itself, okay, the filters will be applied, and that too in the dynamic way. Obviously your performance will be increased.
Hey there! Want to master SAP Native HANA? Our course is here for you. Take it at your own pace on our platform. In this course, you'll dive deep into SAP Native HANA. It's like a toolbox for managing data, from organizing supplies to streamlining operations. Our course covers it all, from basics to advanced techniques, crafted by seasoned experts who know their stuff. Your teachers are pros with years of experience. They're here to guide you and tackle any queries you have. And guess what? Our students love it. Folks just like you have found our course incredibly useful. The best part? It's budget friendly. You get top-notch learning without breaking the bank. Ready to become a SAP Native HANA Pro? Sign up now. For more info, head to ZaranTech's website. Alright, let's test your knowledge. Here's a question for you. Which of the following is a key feature of SAP Native HANA? Option A, traditional disk-based storage. Option B, in-memory computing. Option C, relational database management. Option D, batch processing. Take a moment to think, and when you're ready, choose the correct option. Remember, each choice holds a key to unlocking the answer. Good luck! Type the correct answer in the comments section.
Okay, so in these kind of a scenarios where we know that the range is all defined to us, we don't need it in the form of input variable or input parameters from the business side, we can go ahead with the temporal join, because it's only date what we are looking for. It's not like some other parameter like company code or some specific values, it's just the dates. So with a temporal join, basically you are giving two join conditions. While joining, we can give more than one conditions, right? At what level we have to make the changes, order changes at the aggregation, like the node just below semantic. Okay. In this case, let's say business is asking to give the material type next to the customer ID. What we'll do, just drag and drop. That's it. And now if we'll see in semantic, we can see in the similar way. Okay, and these are the labels which we can change. We can give them more business friendly, provided that business is directly using our views, because typically there will be some UI reporting dashboard like Tableau, Webby. So these labeling can be done there as well. However, if some business is consuming directly your HANA views, so better to give labels so that it will be easier for them. Correct. Okay, for SLT, there was a scenario being provided if we have some count mismatch, correct? So for count mismatch, as I said, you have to go to your server, SLT server only. But transactions which you can check is basically your LTRC. LTRC is your transaction which gives you privilege to check your logs, and not only your simple logs like while we are triggering and checking okay what is happening. It even give you provision to check your application logs and logging tables if anything has been paused or anything has been interrupted, right? It could happen that even your HANA system went down for a couple of seconds, right? So these kind of a thing happen. And usually when I was working with SLT, I have seen that this data mismatch happens when let's say you have deleted something at the something at your ECC side, okay, but those records were already pushed to your HANA. Those delete um updates, like delete information that you have deleted something from your source side, will not be passed to your destination side. Okay, it's a common drawback with the SLT. In this case, what you have to do, you have to explicitly provide conditions that whenever there is a change, update, delete, then also the information should be provided to the destination side. Okay, we can do this with the help of some SQLs while defining your SLT configurations. Further, you can typically check ST22 and SM21 just to check okay any job failure or anything like that is happening, just to see entire job logs, because that there we have to go. There is no shortcut. Yeah, is that clear? Okay, so with this we'll be starting today's module. Okay, I hope the basic joints are clear to everyone, because we are going to move today on rank topic, and rank is something which is very critical as in um, we need to have a very wise decision if we need rank or not, because rank always interrupt your performance. Okay, so better we use rank when we are sure okay there is no other alternative. And also if rank is there is a requirement to perform rank, then better to do it in calculation view only. Don't try to write the sequels in your table functions or procedures unless and until it is very important. The reason being, at least in SAP HANA calculation view, maximum optimization has been done already, how the rank should be defined, so that our performance should not be hampered. So under rank, we are going to discuss okay in calculation view how the rank node look like, the main settings, and then choosing an aggregation function, generating the result set, working with percentage, and rank node and its aggregation. Okay, so the main thing, why do we need rank? Whenever there is a let's say you have a company which deals with the products, okay, which is very common. Let's take Coca-Cola Japan. Okay, with Coca-Cola Japan, you have Pepsi, Thumbs Up. Okay, all these are products. Now they want to understand which product has done the maximum sale in your current month. Okay, top 5 products with their revenue and these kind of information, right? So for those things, rank is required. So top 5, let's below bottom 5. Then while defining your rank, it is very important that you uh, partition your data set, not physically partition means you are actually dividing your physical table into different table set. The reason being the volume is huge. But here when we say logical partitioning is your table is same, but while fetching your data you are grouping it into certain things. Okay, that is logical partitioning. So before doing your rank operation, because aggregation is required, because let's say in this example we want which product has done the maximum sale, right? Number of customers are there, so we need to understand, okay, on the level of product on this time frame, what was the total sale amount. So in that case we need to do aggregation on these two columns, your product id and your tenure. Okay, in these two things, so logical partitioning will be there. Then for each and every partition, sorting is also required, because rank can only be done on a sorted data. If your data is not sorted, your rank will not perform. So that this is the reason that we are saying that whenever rank is required, better to do in calculation view, because sometimes it happens that while doing it in a other scripted manner, you may miss to sort your data. And then aggregation is applied because we are doing it generative. It could be absolute value, in this case it could be percentage. Okay, and then target offset or anything like that, I'll explain about what is offset. Then the direction you want from top to bottom, like top 5 or bottom 5. Then if you want your rank column to be displayed while showing your data, the first thing is we need to understand logical partitioning is required. So I think in this what they're doing, they have some country, product id and gross amount. Okay, so these 3 columns are there. They want to see data on the country level. Okay, the grouping is going to do on the country level, and then the aggregation will happen and the sorting will happen for your amount. Then they are saying, okay, we want the top records from top to bottom. And then they are saying, so target is nothing but how many values do you want, because you may have a huge data, right? But they just want top 5 um, records here. So in that case we are giving the target value is only 5. Okay, we are not providing any offset. Okay, what is offset? Like you want to skip something. Okay, uh, 2 rows are getting same count. Okay, in that case you want to keep only okay, let's say 3 rows are getting the same count, same rank. In that case you just want to pick up only 2 rows. In that case you will provide offset is 2. That if more than 1 records are getting the same rank, then how many records you want to show in your top 5. Okay, in that case we will be providing offset. Yes, here what we want to generate the rank column which will show what is the rank being provided. Okay, so we want, and the name has been given as rank. And then what we want to return along with these two, we want to return our each return now will be related to a product id, that for one product id in a particular country what was the gross amount. And the sorting has been done descending, like from maximum amount to least amount. Let's read. So they have provided the settings as we have discussed. The result set is nothing, that top to bottom or bottom to down. Then the result set type is absolute. Absolute is like there'll be a value being provided, that's like a floating value. Then you have your target offset, number of rows you want to return. Then rank column, we will be generating it, logical partitioning and sorting. Okay, so choosing an aggregation function. So with the aggregation function, what will happen, we with the rank node we have only 4 conditions. You want row number, you want rank, dense rank and sum. Okay, let's see this with example. Let's say you have a country, product and sale. Please see your data very carefully. Country is C1 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 C1, C2 C2 C2, 4 rows for C1 and 3 rows for C2. Then you have product P1 P4 P2 P3. Again you have P2 P1 and P5. Okay, the sales is 180 and that's numbers. Then let's say you want to show your row number only. You are not supposed to do any ranking operation. What will happen, as we know, the partitioning has been done on country level. So what will happen, these 4 records will be grouped together and these 3 records will be grouped together. Is that okay? Yeah. Then second condition is we want to do it on product level. Grouping is done, then aggregation will happen at the product level. So what happened here, we have P1 P4 P2 P3, so nothing is common. So basically these will be different 4 rows, 1 2 3 4 1 2 3, nothing is common, right? If in any case P1 P2 would have been there, P1 P1, so what would have happened, 100 plus 80 180, and then row become 1. Yeah, in the case of row. What is happening with rank, with rank we are saying, yeah, grouping will happen for the same country set, again same country set. Then what we will say, we will say that your measure is nothing but your sales. All are 4 different products, so grouping they cannot be clubbed together. The only thing which can happen here is they have same sales. 2 products have the same sales, so they will be at the same number, 1 2 2, and instead of writing 3 we are writing 4. So 3 has been skipped out. The reason being, with the rank we does not give same value, like the sequence will not be maintained, it will be skipped, because we will be checking at the row level which row is coming up now. So with rank we are not maintaining the sequence of numbers. Okay, with the dense rank what we do, we maintain the sequence. However, it is a row number 4 but the rank will be given as 3. Okay, and this is nothing is common, so it's giving 1 2 3 1 2 3 1 2 3. Okay, what will happen at the sum, sum is on the basis of your sort. Okay, we have done the sorting at the descending level, that highest value should come first, then lowest and so on. So first in the aggregation with the row 1, okay, 100 will be visible, with row 2 180 will be visible. If the aggregation the sorting has been done on the ascending level, then what would have been the scenario, with P3 product it would have been 70 and the row would have been 1, then 70 and 80 150. Okay, then 150 would have been your row number 2 and so on. So this is why aggregation sorting is important, that at what level you are sorting, accordingly your aggregation will happen. Okay, let's say what they are writing, they are saying result set type is absolute because we are summing up the values. Logical partitioning is by country, sorting is descending, then standard row number is ties have different row, so they have explained what is it, Each and every tie has a different row number. Then with the rank, they have same rank. With the dense rank, they have same values, but there is no skip, no gap. Okay, the sum is order by column, cumulative sum, cumulative values. Generating the result set. Okay, so the setting must be with the rank. For example, rank 2, they are talking about offset, I think. Aggregation target value 2. The setting, for example, extract the data rank 2. Okay, it's like we have done for 5, right? So basically they are doing fetch only value till 2 at this level. Here they have provided 5, right? Target values. They are saying it should be, if it is 2, then how the data will look like? It will just fetch your 2 records. Okay, and then in rank it was 2, and your result set, the rank 2 was given till 3 rows. That's why 3 rows has been populated. And then for sum, it's 2 rows, so only 100 and 180 is been populated here. Okay, if the case has would have been yeah, in any way, rank or dense rank, both will be same. Yeah, in here, in the case of sum, instead of rank, we will be giving some cumulative value. This is the difference. Okay, if I'll create a rank tomorrow, I'll show it there, because rank is very important. Okay, so with the, if we say it target value as instead of row in the aggregation function, if it would have been sum, then in the target fix we would have given 200, 100, like that, some absolute value. Okay, in this drop down list we have row, rank, your sum, like these we have available. Okay, then working with percentage. With percentage also it's almost similar. Is that just that your absolute values get converted into percentage, and then in your target you define the percentage like 0.5, like a target value is 0.5 or 0.3, like that. Your all absolute value automatically get converted into percentage. So they have, I think, given some examples that, let's say business want to see what are the 50% best selling products for each customer. Okay, in that case what will happen for customer C1, C2, C3, like that, they will be they will be checking what product they are like buying maximum time, 50% sale they are doing in the provide time frame. They are giving some pointers about rank nodes and aggregation. So it is possible to exclude a number of elements from top of sort by giving the offset. Have they given an example here? Yeah, they have, I think. When the source data from rank node is a table, you must make sure the structure suits for modeling need. If not, you might need to first aggregate by adding an aggregation node used as a data source for the rank node. This is what they have said, right? If your data is not up to the mark, you are required to use your aggregation node. By default, it's aggregation node only. When the source data of rank node is cube calculation view, the aggregation define in that calculation view is implicitly triggered based on the column requested for the rank node, but the column is mapped to the output rank but consumed by a, okay, this may happen that you are doing a rank on some columns, but at the semantic level you are not using those columns on the basis of which you have done your rank. So that is possible because those are not required, but business wise, from the logic point of view wise, you need to use those columns and then you are not consuming it at the semantic level. Let's see what they are trying to demonstrate here. C1 same data. What if you do not want the sales order ID in your calculation output? Yeah, it's like they are hiding. Okay, they doesn't want sales order ID. C1, P1, C aggregation has happened for P2, right? For C1, it should have been C1 customer. Okay, they just want for P1. I think here the offset has been maintained as 1. Okay, so that's why what is happening, they are just reading C1 country wise first product and C2 country wise first product. Okay, 1 that this is what they have been doing here. And then at the aggregate country before ranking at a product level, what will happen? C1 P2 170, they're combining these two. Then C2 P2 120, 1110. Okay, before. So basically the main logic is that you need to do aggregation and sorting before applying your rank. In this presentation we'll be reading about variable and input parameters, impact of variables and input parameters. If we are not able to cover this fully, maybe we'll cover one topic out of these two, maybe input parameter or variable, so that tomorrow we can continue with the remaining topic. Then
I
creating
think
variable.
Diksha, I mean Thursday, Friday, Saturday only, right? Sunday is not there, right?
Tomorrow I'm in the next class.
Yeah,
When we have,
correct.
yeah.
Yeah.
Yeah. So creating variables, input parameters, calling an input parameter, then using dates, calendar dialogues for input parameters, mapping of variables and input parameter, cascading prompt architecture. Okay. So variable and input parameters, many of you already know, as the name itself suggests, something coming from outside the view and filtering your data. Okay, and just to inform you, initially there were only variables. Okay, when SAP came up with the concept of external filters, they just started with the variables, but later on they have introduced input parameters, which actually over the time variables totally got replaced by input parameters because they are more effective. Okay, but again there are very minimal scenarios where we are go with the variable as well. The end user consumes the data will be prompt to the provide attribute values or parameters, either to reduce the data set or trigger calculation based on the provided parameters. When we say calculation based on the trigger parameters, it's like aggregation, let's say. Yeah, when someone is providing some value, in our case we had 5 materials, what we saw just now. If user give only one material, okay, and they provide some they provide from the input side, we have, let's say, id also, person id or whatever the second set, which is your person who has purchased, okay, that product. So in that case our aggregation is getting changed, correct? That is another one of the thing calculation for from business point of view. Or also there could be scenario that we have provided a logic within a calculation view to filter the data, as in, okay, in the next class when we start doing filters, we'll be seeing in our expression section. Basically here with the input parameters we have couple of choices for parameter type. Direct is like you want it to be driven directly from help of some columns, okay, or you want it to be on a specific column, so you can get that value from your table functions or anything like that. Okay, what will be a reference column. Then you also have direct is like you are giving some specific value here itself, that okay, it's a constant value, and what is your filter going to be, value is, let's say, then it's a unit of measure, and data type, if it is a measure, data type is going to be, we can give integer, it's a single one value, right? Length and all those are not required in case of integer. If it would have been float, then we need to provide the scale and length, everything. So with integer, it's a single value, right? So we don't length and all. So in this case, we are defining a constant input parameter which will be same all the time. Okay, it's not going to be changed, but the filterization will happen. It's like a filter being provided at which will be visible to everyone what filter we are doing. Okay, another thing is, you want, it's a simple scenario which is mostly used when your business is giving a value at the runtime, and that value can be provided on a specific column which you are providing. Another is derive from a table. We may come up with a scenario that let's say you have a master data table holding information about regions. Okay, in that way what will happen, we will use that table name here, okay, and the reference column. Then we'll say what value will be returned, and we'll say okay, what columns will be filtered out. Okay, while defining it I'll show you, because we need to have some uh, knowledge about the data set, that which data will do all those kind of operations. So in the next class we'll be doing some lab activity for this. Okay, so typically how it work, you provide a table, you give a return column. Okay, with that table what actual value you want to get from there, and what kind of filter you want to provide. Okay, and then yeah, this is the table that we can drive it. And usually this table is not like a transactional table. No, it will be a master table. Okay, because with the transactional table performance will be reduced.
Hey there! Want to master SAP Native HANA? Our course is here for you. Take it at your own pace on our platform. In this course, you'll dive deep into SAP Native HANA. It's like a toolbox for managing data, from organizing supplies to streamlining operations. Our course covers it all, from basics to advanced techniques, crafted by seasoned experts who know their stuff. Your teachers are pros with years of experience. They're here to guide you and tackle any queries you have. And guess what? Our students love it. Folks just like you have found our course incredibly useful. The best part? It's budget friendly. You get top-notch learning without breaking the bank. Ready to become a SAP Native HANA Pro? Sign up now. For more info, head to ZaranTech's website.
Transaction table will be holding huge data. Master data are usually very limited. Like in our case, we saw only 6 products are there, right? Even in the case of big organizations, we may have 200, 400, 500 products only, not more than that at the aggregated level. So master data is the only thing which we will use while defining your derived from table. Then static list. In the static list, it's like a constant only. Okay, we can give more than one values here. We can describe, okay, what is the value and what does it hold. Okay, but it is, instead of one direct value, we can give more than one. Derive from a scalar function. It's like you are providing a table function. From there you are fetching your value even with the procedure. This is very commonly used in when you have huge data set. Okay, like we can't do it with the tables. We first limiting our data at the scalar function level, and then we are consuming it. Okay, in this is the typical scenario when we go with the drive procedure, that we have a huge data set, and to limit the data we are first doing a scalar function, and then we are consuming it. Variable and input parameters enable dynamic information, reduce trigger and calculations. So this is the reason we check that while triggering we are doing some sort of a calculation also. Let's say your trigger functions, scalar functions, right, there also we are doing something. So this kind of a thing will happen automatically. Then what is variable? Variable are used to filter the content of an information model. They do not impact the execution flow of the information model and are applied to query to the filter out some values. Variables can be used to filter attributes. For example, variables can be used to filter a result to a specific country or a specific customer. When filtering using variable, a where clause is added, just like added in a SQL query. This is the only difference. Okay, so what we say when we I think in last class only we have discussed what happened with the where clause and what happened with the input parameter. With input parameter, your data first get like filtered. Okay, like at the projection level it will read, but then it will filter. But at the where clause, at the variable level, your all operations, like you are doing some joins, you are giving doing some calculated columns, everything will happen, and then where clause will work, then your variable filter will work. So this kind of a filterization is required when your logic has been provided, but then also you know that there is a scope to filter your data, then you can go with variables. Otherwise, when you know that you can filter your data at the projection level, then you will go with the input parameters. So what is best, right? If we reduce our data at the bottom level, that is best. But again, what is second best thing? That we have done the filterization with the input parameter, but again there is a scope to filter your data, we will go with the variable. Both can be applied in the same views, and variables are only applied at the very top layer, which is directly getting consumed in your application or your dashboards, because it is not changing anything in your not reducing any time in your calculations, right? It is just filtering your data at the where clause level. So this is the reason we always apply variables only at the top level, the top layer view, which is directly getting consumed, or input parameter at the very bottom level to filter your data to the max. Okay. Then calculation performed by model can use input parameter as input values. Input parameters can be used as a compulsory for evaluation of an. Okay, there is another concept: mandatory and non-mandatory. With input parameters, we have a feature. You might have seen that some of the documents, when you fill up on any of the front end side, right, any of the application, some are marked as asterisk. Those are mandatory to fill. Before that, it will not process a document to the next level. Similarly, here in HANA, when we give the input parameter, it is up to us how we are designing. We can make them as mandatory or non-mandatory. So what will happen if anything is marked as non-mandatory and user is not providing any value to it, it is blank, then also the value should come. In that case, what will happen? All the values will be appeared, right? And with the mandatory, user should know what value has to be provided in your mandatory field. So what we will do, we will use the list, and now we say it is mandatory. Okay, and then we say it's not direct, it's a derived from a table or maybe static list. So what I'll do, in my static list, I'll say constant. So basically in static list, we'll be giving some set of values here. Okay, and then we'll be just taking up those values from here. Okay, in case of derive from table, we may have let's say 4 or 5 values being provided. From that list only user will be able to show it. User will be able to provide those values. So one there'll be 3 dots just like this. Okay, and when you click on that, there will be drop down list being provided. In that drop down list, those drop down list is coming from your static table or static how you have defined here. And if business come up that okay, we have new material being added, we want that material to also be populated in your options drill down list, in that case we will just add that particular new material into your master data table and it will be visible. In this case, we will be doing a best practice, because we are not changing all the views, going manually and adding with the help of constant, how we have provided. So it's always recommended that when you have more than one values as your input parameters mandatory, you create a you create a physical table and hold those values, and whenever requirement any new thing comes up, just insert a new row into it. Okay, so this is that example. I hope this is clear, right? Okay, then okay, so they are defining what exactly happened in the case of input parameter. In the case of input parameter, the value will be provided in the form of, when we do a, okay, there is something which is very helpful. when we go to data preview, this is a tab which is show logs. In your show logs, you have generated sequels. Okay, so when you start seeing this, whatever grouping we have done, automatically it will come. Okay, even if you provide a filter and you want to check, this will come. So in case of input parameter, whenever input parameter is defined, and you will check in the data preview what is happening when you are giving a value, the value will be coming with the help of a placeholder. A placeholder like this. Okay, whatever you have defined, in this way your column will be provided. Okay, this is what, and the value is this. It will be under $sign. This is what they are saying here. In the SQL view, how, if we see how it has been generated, it is generated with the help of a placeholder. Impact of variables and input parameters. Okay, impact of variables and input parameters. You can use variable to filter your data at the runtime. You assign value to these variables by entering the value manually or by selecting it from drop-down list. Using variables, have we done this? Using variables means that you do not need to decide the restriction on the value of the attribute at the design time. Okay, let's read about input. Okay, so variables are basically used to filter data at the runtime. That's true. Then as variables, basically we enter the manually or drop down list, that is just like input parameters. Then with the variables, we are not restricted to provide attributes. So with what happened, in the input parameters, when we define them, we need to inform that okay, this value will be similar to this column, like that, right? Here there we say okay, the input parameter, we need to define an attribute associated with it in the case of input parameter. However, in case of variable, we don't restrict that okay, the value will be similar to this column or that column, and it will always belong to this column. We just create a variable. In that case, the problem what happen is, if business give any non-acceptable value, then that becomes sometime a challenge to inform business that okay, this value should come, and they say okay, we are giving this value. Let's say they are giving in a lower case, okay, and in our data we have values only in the upper case. Business will expect okay, the value should come, the results set should come, but this is not happening that way. So what we as a developer have to do is, we have to make our variable in such a case that whatever value been provided, it will automatically be covered to the uppercase, right? So this is how it is. So you might have seen sometime when you enter a value in a document, result is always in the uppercase, and even if we give a uppercase, both the cases are accepted. So in that case, it becomes some case sensitive information, and we have to handle it from backend itself. And what is this? Store row engines, calculation engine, client. Variable type, single, interval, and range. We can have a single variable also, interval, and a range, less than, greater than. Creating a variable. So to create, I would like to inform that in this presentation, each and every screenshot is from the web ID. Okay, web ID is from HANA 2.0. Access came into picture, right? Advanced HANA has been came into picture. So with that, to make it compatible with the latest technology era, we have something called web ID, which is nothing but your URL only, where you go with the help of a HANA cockpit. Okay, this is the screen, how it looks like, HANA cockpit. Okay, this you may have access to it in the development system. Okay, but usually this has been handled by basis team. Okay, from there only they generate one link for us as a developer where we can go and do our development. In this, as you can see in this screenshot, let me try to increase the size. Okay, so here if you can see resource directories, right? So we have 32 resources. Resources means um, 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 like okay, resources is for that directory, how many uh, locations has been provided to store your data. And that storage is not only in terms of technical objects, it's more than that. Okay, then in production there are how many resources are being running. So you might have seen that in the case of failures, right, more than one resources are there. So in case of issues, if one is down, automatically another host will be active. Development is like so it's each and every thing we have resources, and each one do a different kind of a thing. Okay, managed cockpit is something from where they give a URL to us. Admin is where all the services are being run. So like this we have something called SAP HANA cockpit, where the entire performance uh, giving, let's say you have a complete HANA database and you're dividing that database into four landscape. One is for development purpose, one is for quality, then your pre-production and production. So each and every division of your HANA database will be happening with the help of this screen. If we go further in each and every tab, there'll be lot many things. Okay, so from here only they'll be giving us something called HANA Cockpit Web ID. If you see, this is how the web ID look like, where you do your changes in the latest format. How it is, you create your files. Okay, whenever you have application which is not like reporting application like Tableau, web ID, uh, sorry, Tableau and Webby, these kind of things, when they are not there and we are supposed to publish our views into a UI. Okay, in that case many things are provided in this. That's not the scope of the project, this training. However, we'll try to touch as much as possible. Okay, so this is something which comes up when we talk about the screenshots. In these screenshots we have covered something similar to this place. In the web ID we can do a graphical way also, so those kind of things has been provided, which is similar to native HANA itself, but those are more like compatible with the applications which are non SAP. Like we are not dealing with the SAP world, we have some other platform altogether, so interaction with them become easier. Okay, in this like we filter usually in the HANA Studio we have filter in the right hand side bottom, right? But here we have everything like this, so little bit of UI will be changed, but options and everything would be same. It's better to do it in lab time. So basically they are creating it at a semantic layer. Okay, variables are created there. When displaying the data, condition, variable or input parameter, the value dialog help the user to check what all possible values are there. Right? The UI is different, you know, how it has been displayed in the web ID and HANA Studio, that is only going to change. Nothing much. You might not want to variable to just retrieve the data to view. So what happened with the input parameter? We don't want that business should give specific values, right? In that case, input parameter would be better. You might want to take input from the user and process and give a dynamic result. Input parameter make it more possible. So here also, as we seen in the lab also, HANA Studio, we have direct currency. These are the types: direct currency, direct date, unit of measure, static list, column, derived from a table, derived from a procedure, direct without anything. Then if you want the end users to decide whether okay, all these are lab specific basically. Let's do one thing. In the next class we'll cover the lab part for input parameters and then come back to this presentation. Okay, so we will be covering theoretically we have covered most of it. We'll just read it out in again. but we have covered theoretical part of input parameter. In the lab, we'll do it again, each and every condition, and then we'll come back just to go through it again. Okay. With that, we'll try to cover this topic. So basically, hierarchies are can be of two types. Level hierarchy, which we just now discussed. One of the example, parent-child hierarchies. What happens there is that you need to specify some relation among your attributes. Okay, like what is the parent and what is child, and we need to understand if a child can also be a parent for some other attribute values. So these kind of things has to be understood before coming to a decision. Okay, so SAP HANA model helps create hierarchies to organize data in a tree structures, right? For multi-dimensional reporting. What is multi-dimensional reporting? That you need to show data at a different grouping level. Each hierarchy comprises of set of levels having many to one relationship, but each other and collectively these levels make up the hierarchy structure. It's the same language actually. Basically, each hierarchy has a set of level, right? And the level could be one to many, many to one. Like first your region, that is many. Then you have your drill down further. So particularly it will come to a specific one part where it can't be drilled down further. A typical example is time hierarchies when we want the physical year and then quarter, month, day, and so on. Okay, that level of data. Level hierarchies, what is it? The one we have discussed. In level hierarchies, each level represents a position in the hierarchy. For example, time dimension can have a hierarchy that represents date, data at month, quarter, and physical year level. Level hierarchies consist of one or more level aggregations. Aggregation, see, unless and until you have an aggregation, it doesn't make sense to go for hierarchies. Another thing. Okay, when you have data at like some measure, then only it makes sense to go with hierarchies. Otherwise, there's no much of a point. Hierarchies typically comprise of several level of data. You can include a single level in more than one hierarchy. So, what we are saying here is, let's say you have a data at regional level only. You don't have so like drill down further, but that data also we can make it as a drill down level. Okay, and also I think they could say that from this statement they can also amplify that. Okay, a typical comprises of several levels and you can include a single level in more than one hierarchy. So even like it's not mandatory that we should have levels also. We can just give one column in the level part and we just say okay, we don't need hierarchy at further level. This is what we just need. Okay, this is working. I'll just show you. Okay, so we have hierarchies here at the semantic level. To create any hierarchy, we are supposed to go here to create. Then we can give any name. Let's say we are giving hierarchy for level check. Then we have two kind of hierarchies available, level and parent-child hierarchy. Okay, we go with the level hierarchies. In here, there is something called node style, where what happen is that let's say you want to show at the name of the column. Okay, so you just want to show the name of your column, or you want to show the entire path. That okay, first you have your region dot, you have your country dot, you have your city, like that. Or you just want a label like okay, this is a highest level like L3, L2, LN1, like that. Okay, in this case 1 2 3 level will be maintained at the name of column along with the column. So what we usually do, we always select name only. It is more easier for the business also. Then we select, okay, which column do we need? So let's say we have date will not be good. Mandate is something material number. What all do we have? I'm randomly selecting anything. Okay, and then we are defining the order by. Usually we keep it same. Otherwise, we can change also that these elements should be grouped by some other column like that. Okay, then in the advanced section, we have these checkbox available. In this checkbox, aggregate all nodes means you have your aggregations, and for different level, like you have level 1, level 2, level 3, then you want the aggregation should happen on all of them, or you want whatever is aggregated till this level, that should only be visible. Okay, let me try to explain this with some Excel sheet. So what if this quantity is not at the row level? Okay, if this view which I am trying to consume in another view is holding up already some summation data, which is a final data for particular row, and further that no aggregation should happen. Okay, the value which is already available in the measure quantities, it's already your final quantity. Let's say it is a summation of some aggregated data, and while creating a hierarchy on top of it, you may receive similar attributes but different values. Okay, so in that case, you don't want aggregation should happen. Basically, you want to treat it as a projection node instead of aggregation. So what will happen? We will basically, this checkbox will be disabled, will not be marked. So in this case, what will happen when we drill down each and every quantity, how it is being written at different row level will be like that only. It will not get summed it up. Usually this has been kept as aggregate at all nodes because uh, we don't give the final value, final summation, unless and until all the operations have been done. Okay, if it is happening so, then at the presentation level where business is consuming, we may have some data discrepancies. So better you check the data, and unless and until it is projection, unless and until it is master data only, with the aggregation already provided, we don't uncheck this box. Okay, then convert empty string. This, as I already said, when you have some empty string and you want to make them as null, this is always checked only. Catch, like if business is running again and again the same set of data, then very minimal data will be, basically it will be cached so that the data view time would be lesser. Okay, add root node. If you do not, right, in this case there will be nothing mentioned in your very bottom level. Okay, the node details basically, so it's always provided as add root node. Okay, then time dependency, if you want to have data in some particular interval, or if you want to have some data in some specific key dates, instead of interval we want some key parameter. So in this case we can go with validity period. Otherwise we can provide the columns itself here, that okay, from which column the business wants to check the data. So basic things we have already done. And here also we can change the sequence. Let's say you want to change the order by, you want to move up and down, so those things can happen. Okay, so you can see this has been created. I'll just click on activate and save. Okay, so what we can try, we can see if we can have analysis for office already defined for us. Otherwise, what typically happens, you may have any sort of reporting tool. We'll try to see if we can show it on analysis for office, but we provide our data from here, provide host details and username, password, everything just like we do it in HANA Studio. And once we give the view name, then in the default area, okay, usually this sheet will be divided into two sections, left hand side and right hand side. Right hand side, you will be able to see your columns name and your filters and everything if you have applied any. And left hand side, you will be able to see some default columns being already populated once you select this view. And those already provided columns will be nothing but those columns which you have selected in your HANA Studio as a hierarchy. Okay, so this is how it is basically. And this is another thing about, okay, let's do it. Instead of saying we have created on order 2, okay, right click, where used. Okay, if you see this table, this is very helpful whenever some analysis is required. And you need to understand, okay, the view which you are trying to analyze has been consumed or been created by which all tables and those things. So where basically when you want to check which view has been created, you can provide the base object name. Let's say in my case, I want to check this view, right? I'll go to my property section. I'll just copy this name from here. Just provide your name because there are different conventions how it can store in HANA. So we'll just do this. Then also we can see 19 records. That's okay. If you can see here, all your base objects are nothing but this. Then view. Okay, then basically what happens, dependent object name is something you are looking for. You can see here that each and every column is been visible here as a different row. So we can provide some filters like you can say where dependent object name not having this HIER. Okay, in that case you will be getting some limited columns, limited rows with these names. So we can see that these are not being consumed anywhere. And this is your dependency level. It's saying that okay, this is your base object, and then it has been consumed in your hierarchies like level 2. Okay, so there's nothing been on top of it basically, so we are good. What we can do, we can create one more calculation view. There's one option while creating a calculation view, you can create a replica of already existing calculation view. Okay, we are not doing that, so we are graphical cube, and this is good. Okay, see, if you see here, we don't see anything at the hierarchies on here this level. So the idea here is, but this was available if we were consuming if we are creating analytical view. Okay, with them, if we create at one node, consume it, then we were seeing your hierarchies directly getting visible at your semantic level wherever you are consuming it. But with the calculation views, we are supposed to create it again. Okay, so that this is the reason that it is always created at the very top level, right? Because we are not doing any aggregation at the node level. We are basically giving a feature to our business that this is how we can do. So it's always done at the top level. Okay, root node, if you want to have it any fixed value or any input variable, input parameters, so those things we can select from here. Okay, that okay, like it should start from so and so value, right? What business is providing. In that case, we can just do it. Okay, minimum it should be 100. Okay, so like that we can just define our values. Then we'll just create one only. Additional attribute, if any, we can just select. Apart from this, we should have our attribute as date. Okay, then we go to the next tab. Again, these are same thing. We can have multiple parent. We are not checking that up because we are not very sure about our data. Then default members and these things are not really required. Add node if defined. We haven't defined anything, so we are not going to add anything here. Okay. Then order by, we just want our data to be ordered by this group, and then ascending. Then we should have our numbers. Okay, grouping is done. Then we go to time. We don't have any time preference as such, so we are good to click on OK. So this is how we create, and we'll just say activation.
Hey there! Want to master SAP Native HANA? Our course is here for you. Take it at your own pace on our platform. In this course, you'll dive deep into SAP Native HANA. It's like a toolbox for managing data, from organizing supplies to streamlining operations. Our course covers it all, from basics to advanced techniques, crafted by seasoned experts who know their stuff. Your teachers are pros with years of experience. They're here to guide you and tackle any queries you have. And guess what? Our students love it. Folks just like you have found our course incredibly useful. The best part? It's budget friendly. You get top-notch learning without breaking the bank. Ready to become a SAP Native HANA Pro? Sign up now. For more info, head to ZaranTech's website. All right, let's test your knowledge. Here's a question for you. What is the primary advantage of using SAP Native HANA over traditional databases? Option A, lower cost. Option B, higher data storage capacity. Option C, faster data processing. Option D, easier integration with third-party tools. Take a moment to think, and when you're ready, choose the correct option. Remember, each choice holds a key to unlocking the answer. Good luck. Type the correct answer in the comment section.
Okay, I'll try to do with the data preview how exactly it will look like with this kind of arrangement. Data preview. Raw data. Okay, let's go to analysis. So what we did, we have, okay, we don't need this. We have our grouping. Okay, 55. And then we have, so if this is so, we'll just, in this case, if once the sheet is open, okay, this will be visible. Then business want, okay, they want that they drill down it further, then you will be having something like this. Because we have null also, we should ideally handle this, that okay, when it is null, okay, we need to create a projection. Actually on aggregation level we can't do it. Filters can apply it on projection or on aggregation with the help of input parameters. So what we are supposed to do here is, ideally we should filter our data at the projection layer, that when it is null, then it should not be pushed further. Okay, because if there is no grouping, it should not be visible if that is the case from business side. But we can see at the material level we have some specific values and a quantity responding to it, so it should not be nulled, or maybe we should give one category to it. It can be done with the help of a calculated column. Okay, so basically what is there, at the first, when the aggregation is provided and the hierarchy is given for all these values where we have a value being provided at number also, these all are getting summed up and will be visible at this level. Okay, then coming to theoretical part, they have been defining how to do it. Level name, that we can have just a node id, having a name and then node name, month dot jan, like that. Okay, then you have name only. In name only you will just be having your name like jan. Then path, you will be having your entire node ID comprises of your node name of ancestors, and then you have your root node. All those things will be like this. Okay, I would suggest you to create, and if you already have access to some of the front end, like any like Tableau or your analysis for Office, try to publish that into that front end side reporting dashboard, and then see how these things basically appear. Okay. And you can change, usually we do name only, but you can also try these other two methods. At least you should be aware when business say, is it possible that we can have both the names like parent, child, and your first node, second node, and so on, root node? In that case, we can say yes, we do have. We can provide that way. Okay, then aggregate all nodes. That this is again the sum up of all your intermediate node level. Then default member. Uh, this value of this property help modeler identify the default member of the hierarchy. If you do not provide any value, members of the hierarchies are default members. Okay, root node visibility. The value of this property help modeler identify whether to add additional root column, root node at the hierarchy. Basically, as we said, like typically when we are saying level 1, level 2, level 3 level of hierarchies, then at root level 3 will be visible. But if you want to show some other root node also, we can do this. Then parent child is again like you have your some specific region, and then you have a column being defined as a child. So in that case, this is okay. I'll give a live example. Parent child. Mm, okay, so I'll take example of a company named ServiceNow. Okay, so what happened? They whenever we create a URL for it. Okay, these what all these are, right? All these things, when we click on anything and we get a web URL, and then we click on something else, some other button, then something else is getting generated, right? What is happening here? We have a parent screen, then we have a child screen, and that child screen can also be a parent for the subsequent screens, correct? How that is being maintained at a HANA level. So in these kind of a scenarios, if you see, this is a very huge URL, and usually we just create a home screen with the SharePoint link, and then something like this. If we click here, right, home. Okay, so we have this parent screen, then we can have different tabs, and even if we click here at this, let's say this is a home screen. In here we click on labs, then a child screen is coming up. If we click further, now this become a parent, and so on. So these kind of a relationship can also be maintained in HANA, where if I go back, okay, if you see, just keep on checking this thing, the material, then this, and then okay, usually in here we are not changing anything, we are just going here and there with these tabs. However, with the URL point of view, what usually happen, the tabs keep on adding here, some text keep on adding here. So those text we can maintain in HANA. Okay, and then with each and every click, a new value will keep on adding, and your URL become lengthier, and you will be able to keep this cycle go on till you get your root node. Let's read it out. Parent-child hierarchies have elements of same type and do not contain named levels. So basically, parent-child, it's like we should have some unique values in parent-child. It's not like okay, it has a parent value, then it has a child value, then again a child has the same parent, like same parent, same value. This child can have a child again and become a parent, but that value should be unique. Okay, then parent child hierarchies are value based hierarchies. Yeah, and you create a parent child hierarchy from a single parent attribute. Okay, so they can say that attribute can also be same. Okay, I haven't seen this scenario, we'll try to see this. So we can keep one parent value only, and we can, okay, let's go here. We usually give two different attributes as parent and child. So what they are suggesting is, go here, let's open this. They are saying that instead of this, we can also have this also. Okay, this kind of a scenario, even we need to check when exactly we can do, but looks like this feature is also available. Okay, but I would suggest not to do this, because we may come up with a situation of taking longer time in doing your analysis, because it will check again and again, okay, if this has another parent or not of the same value, right? Parent child hierarchies is um, a parent child hierarchy is always based on two table columns, and these columns define the hierarchical relationship amongst these elements. Other example of parent childs are bill of material hierarchy, parent and child, or employee master. Yeah, so they have given some example, because in the BOM also we can have that, okay, one bill of material is becoming a parent for like bill of material can have another bill of material. Okay, so this way they have been giving this example. Then in master employee master also we can have it, like one manager could be an employee, and then let's see, like you are a team lead, right? You are managing a team, and then you are also an employee for the manager, correct? In that way it is becoming a hierarchy. There also they are having the properties that you have aggregate, all the nodes, default members, root visibility. Let's read it out. Root node visibility, add root node if defined. So when we have anything defined, we can add them explicitly. This is applicable only for parent child hierarchies. Model add a root node only if you have defined a root node value while creating the parent child hierarchies. Add root node, the modeler adds an additional root node to the hierarchies, and all other nodes are placed as descendant level to this node. We'll check this. Okay, we'll check these options, but usually we just go ahead with these kind of options where we define the properties and aggregate, default, and visibility of your root node. Okay, orphan nodes, what it is? Basically in like there are different scenarios that when the nodes are treated as root nodes only, like let's say you have some nodes where you doesn't have values altogether. It's not like you have some values which are not accepted by the system. Okay, how should I say? Okay, let's say you have a value which is not in the data. You have some values which are not expected by the business. Okay, and in that case what happened, we can define those as okay, let's see if they have provided an example. Otherwise I'll try to get example for this particular node, in what scenarios we use orphan nodes. These are the columns which sometime may have a required data and sometime may not. In this the case when we don't have required data, then how exactly we should make them as root node. So it's a very rarely used concept, but we may come up with a scenario that business want to see a data. Okay, especially this scenario happens when we have just went live. Okay, when we have just went live, The project has just went live, and there are some of the columns where we are not very sure if the desired values will come up. Let's say an example, in your unstructured data, where let's say survey data, when we order anything from the Amazon, there are set of questions. Some of them are mandatory and some of them are like, okay, we give the values as per our interest, okay, right? On those kind of text columns, there also we try to give the values as a value columns instead of as your attribute. We give them as your value columns. So in that case, what happened, we may have some data, we may not. In this case, when we don't have any data, how exactly we should handle them in hierarchies? This is how it talk about. Okay, I'll try to get similar data and then we can check this option. Okay, so this is about hierarchies. I think I have covered almost everything about it. If you have any questions, do let me know. Okay, no questions. Okay, instead of going to currency conversion, we can try going to your SQL part, because these will be covered once we have a proper table, and I will be showing it along with the lab activities. Okay, let me note it down that 11 we have to cover with lab activity. Okay, let's go ahead with the SQL. Module 13, Introduction to your SAP HANA SQL. I think most of you have bit idea about the SQL part, but how the things get changed little bit into HANA, this is what we'll be talking about. We'll be saying, okay, what is SQL in HANA point of view, what to keep in mind while working with SQL, creating and using functions, creating your procedures, creating and using sequence, DB triggers, synonyms, joins, union, aggregations, window and string functions. Let me tell you that windows and string functions are still file, but window functions are something which are many a times are time consuming. Okay. Okay, introducing SAP HANA. Okay, what do we mean by SQL statements? These are nothing but your structured query language. Okay, so some of you might all be aware of that in today era, when we deal with number of responses from customer side while dealing with your and we need to read that data also. When a customer is responding, they can write text in any format, right? And it is not going to be structured, correct? So in that case, SAP should be capable to read unstructured data also. In these slides, we are mainly going to read about SQLs, but we have SAP HANA has already inbuilt features with the help of which they can also read unstructured data and create a meaningful insight out of it. Yeah. So when we have any unstructured data also, SAP handle it in such a way that we have features like fuzzy search, we have features like insights, which we can use at the latest versions of HANA, with the help of which we can create some meaningful data out of it. Okay, and however, when it comes to creating the artifacts of SAP HANA, like creating your table functions, procedures, your scripted calculations view, or maybe your within a calculations view, when you have to write anything related to little bit of sequels, then you will be using your concept of SQL queries only. Okay, let's read out what they are saying. It stands for structured query language. It is a standardized language for communicating with the relational database. SQL is used to retrieve, stores, or manipulate information in database, right? We can fetch it from somewhere, we can store it into a database, and we can also do a little bit of a data manipulation, like a deletion, insertion, and doing some calculations, and then creating new columns, stuff like that. SQL statements perform the following task. They basically used to create your schemas, schema definitions, and manipulation of schemas, data manipulation, system management, sessions management, transaction managements. All those things are being handled in SAP HANA with the help of SQLs. Then the data types. Okay, let me clear this fact that we have read about the different type of table creations, right? Different methods of table creations, how we can create. So what you can see here, they have covered the data types for when we create with the SQL editor option. Okay. We also have a feature to create files, right? HDB files, we call them, which is nothing but CDS type of table creation. So when we talk about the CDS type, in that case, these data types are going to change. For example, when we talk about your strings, in that case, instead of using your varchar and varchar, we use the keyword string. Okay, let's go to your HANA Studio. We'll go back to repositories. Here, I define them as string. They are coming as nvarchar. Yeah, because this is what SQL accept. Within a HANA, it is happening by default that whatever we have defined in the CDS form, it is getting converted into the SQL accepted format also. So you need to understand that if you are dealing with SQLs, then you have to use these data types, like date time is your date, time, second state, timestamp, and binaries like var binary. So like that you have to define them. And if you are working with CDS, it's very well easily available on HANA on their SAP, like CDS to SQL data type. Something like this should be able to give you. Yeah, I think this is what. So it's very easily available. Okay, if when do we need these kind of a scenario? So let's say you have a project migration happening. Okay, you were at the lower version of HANA and now you are migrating to the upper version of HANA. In that case, instead of your HTTP function tables, you are supposed to create this is here, it is not written, HTTP tables, right? And you're supposed to come into HTTP DD data table type, CDS table types. In that case, you are supposed to know, okay, this has been created. By default, SAP has provided number of migration tools also. But in that case also, if you are creating anything in the new system, you should be knowing your data types. So you can refer to these. Yeah. Okay. Let's jump to another. Reserved words. Okay. So as the name itself suggests, reserved words, SAP itself has reserved some of the keys which are understood by the editor that okay, we are supposed to do this. Let's say we are creating a table where it is a key column, right? It is a primary and it should not be null. So in that case, we can use a key word. With that, SQL editor will be able to understand, okay, this is what modeler is trying to do. And if we try to use the same key as a attribute name, that is something where we will be having a problem. Okay. However, if you want to use a already defined reserved word as your column name, give some special character along with it. Let's say key underscore variable. With those kind of a things, we can use the same name, but we can make them as different. I think this is common for any of the relational database. So if necessary, you can work around with the, yeah, this is what the double quotes and things like that. Then okay, we have operators like any other thing, like we have strings, then varchar and varchar, like that. You have comparison operators also, you have logical operators, set operators, binary operators, then arithmetic operators, stuff like that. So we'll just see one by one all of them. When you have a column and you don't need some other column to do any manipulation or do any change on top of it. See, let's say your note operator, that where attribute should not be like this, right? So in this case, you don't need any other operator to have a comparison or to have a any sort of a decision making operation. Only one operator is sufficient enough. In that case, we call them as unary operators. Okay, we don't need like single value of expressions. Then binary, when you need two columns to make the logic applicable to it. Let's say if you are adding anything, in that case plus operator, and then you need two attributes. So these kind of operators are usually called as binary operators while doing your comparison, while doing your addition, subtraction, stuff like that. Okay, then let's say you have an expression in your filter and you are doing a and operator or operator, you have your not operator also there, you are doing a summation, and in these kind of a things, what will happen first? I think in the schooling time also we have already done this kind of exercise, where if any expression is been written within parenthesis, we just say okay, which operator will get executed first, okay, then the other one. So in this case, if you can recall, when we have subtraction and multiplication together and we have addition and subtraction, so in that case these two operators will happen first and then your addition and subtraction will happen, right? So this is how we are supposed to know this way. Otherwise what happen, we create a expression in your maybe calculation view or in any of the areas, your table functions procedures, then we are expected some result, but that is not working the way we are expecting. The very first reason could be you have defined in a certain uh, logic where operators are not working as per the expectation. Okay, then arithmetic operators, simply like when you have plus, then what will happen if you have two nulls, then none will come, and subtraction. So this is how it is, right? Multiplication, then this is how when zero. Okay, when we are doing this thing, division operation, this is a very important, that we should always get a defined value. If we get undetermined value, that will be a problem, because in that case it will neither be null nor be zero. Okay, so we are supposed to have a value that whenever it is coming as let's say how we handle it with the divide operation, you have divided x divided by y and the value is coming as undefined. In that case, in the system, usually it is defined by null. Okay, and it will come as error. Okay, so you can either define that when it is error it should be 0, or you can say when it is null the value should be 0. So whenever you are handling division operators, always handle them with a case statement. Yeah, so when a divided by b, then when a divided by b, write your cases. If it is 0, then the value. If it is null, then 0. If it is any value, then yes, go ahead. Like that you have to create your cases. Otherwise, while you're doing your aggregation, you will be encountering problems for sure. Always handle your this thing with case operators or if else conditions.
Hey there! Want to master SAP Native HANA? Our course is here for you. Take it at your own pace on our platform. In this course, you'll dive deep into SAP Native HANA. It's like a toolbox for managing data, from organizing supplies to streamlining operations. Our course covers it all, from basics to advanced techniques, crafted by seasoned experts who know their stuff. Your teachers are pros with years of experience. They're here to guide you and tackle any queries you have. And guess what? Our students love it. Folks just like you have found our course incredibly useful. The best part? It's budget friendly. You get top notch learning without breaking the bank. Ready to become a SAP Native HANA Pro? Sign up now. For more info, head to ZaranTech's website.
Okay, single operators. Single operators are like concatenations. Okay, where you are joining two strings. Let's say you have a requirement. You have, while getting your data, you have two columns for your first name and last name. However, while showing it into your report side, business want to club these two names together. So what we can use concatenation. They have provided a point here that when varchar and nvarchar are clubbed together, okay, their starting prefix and trailing space are retained. If either string is of data type nvarchar, the result has data type nvarchar and is limited to 5000 characters only by default. The maximum length for varchar concatenation is also limited to 5000. With this, I'll give one more example. Let's say you have nvarchar and you are clubbing them together. Okay, and then business want that there should not be any space in between. Okay, it should be a continuous value. Let's say uh, employee id, yeah, and employee department, it should come together. Okay, in that case what will happen, if there is any space between your after your name, yeah, usually we have a practice, right? We give our name and hit space bar, hit enter or space bar. So in that case what happened, while storing the data itself there is a space, but business doesn't want that. So in those cases we are supposed to use the operators like trim or left side, right side, like these. We have some business defined operators. So in that case we can use them before doing your concatenation, or after doing your concatenation, no, before only, because otherwise it is difficult to do it in between. So before concatenation you are supposed to trim your columns and then concatenate them. Okay, comparison. As we have discussed, like equal operators, greater than, less than, greater than equal to, or less than equal to, not equal to. So these are the operators for comparison. I hope you all already know about it. Logical operators, very important, and sometimes it's very difficult to understand or predict the behavior using these operators. Okay, so AND operator is when condition 1 and condition 2 both are matching, then only you will be getting your data in the select portion in your result side. Or when any of the one is true and of both of them are true, in that case you will be getting your data. Not when some expression we have written like, okay, quantity should not be equal to 0, correct? In this case we will be giving only those records where quantity is more than 0 basically, and it should not be equal to 0. So in this case it's a very basic example which we have given, but trust me, when we start applying them we encounter situation that the way we have expected, the system is not working that way. The simple funda is that you need to understand which operator you are using. Many a times I have seen that teams comes to me saying that it is not working how we are expecting, see and is working and stuff like that, right? So just understand how you are using these operators, logical operators. Set operators, as the name itself suggests, when we are trying to get a set of data out of your full records. Okay, union is, as we have discussed during the union topic as well, that when we want to combine two different queries expression together, that time we use union, and where we want distinct records only. And then union all, we want to club two different data along with their duplicates values, intersect, getting data 1/2 except is we want everything apart from some specific condition. So in these four cases we can use them. Case statement. A case statement, a case expression allows the user to use if then else logic without using procedures in SQL statement. So what happened is like with the if else conditions, those were basically we were using in a mostly in procedures. Okay, so what we can do if we are using table functions and those areas, so it is very much easier to use your case statements. Case expression allows the user to use if then else logic without using procedures in SQL statements. So we can just copy and try to use your case expression. So how basically case expression work is, a simple case expression is basically when we have a case, let's say mm, column name. Okay, when your expression is happening, then something should come. When this is happening, okay, so let's do it during the table functions time. Okay, we'll give some scenarios and we'll see how the data is getting changed, but I think case statement is mostly understood to everyone. And when we are searching something, okay, it's a simple case statement, but they have given some scenarios that when we want to search something, then we give a condition instead of expression. When uh, column 1 is equal to, let's say some value, right, that nothing but your conditions, in that case it become conditional specific. And when you say, okay, condition is also like when you say column 1 should be greater than column B. Okay, so in those cases also it become conditional case. Okay, yeah. Then we have something called two types of user defined functions: scalar functions and table functions. First of all, what is the use of different functions, and how it is been different from your procedures, because there also we are using your SQL statements only to get anything done. The basic funda is your user defined functions are basically a read only thing. Okay, we can't really go ahead with the DML operations like insert, update, deletion. So in this way you have two kind of it, scalar and table functions. Scalar function is the simplest database object for which you can make use of SQL scripts are scalar. Okay, and what we are doing here, we are defining the name, input parameters if there are any, along with their type, and we will be returning a set of values or a return parameter name, or we can also have some table basically as a return. It will be only a single value. Okay, then we provide the business logic. However, what is the thing here is that contain expression within their body, used in a field where clause and statements inbuilt operations can be used. They can directly be called into another user defined functions as well as in the stored procedures. So let's say you have a scenario where you are joining two tables and you are providing some operators like and or, and you are doing some of the things which are not possible with your calculation view in your user defined function. And then it's a repetitive thing, like whenever let's say you have four different kind of a systems. Okay, you have four systems, you're getting data from four systems of same time is for some one application that is going to be consumed in your reporting side. This is how the landscape is for any native HANA. You have your source system, you have your HANA in between, and then you have your reporting side, or any place which is directly consuming your reports, your views, and these things, right? So in this case, before creating your reports, you have your different systems. So to join different systems, we are using some same set of SQL statements. Okay, instead of doing the repetition work in your procedure, that okay, you are writing same set of SQL again and again. What you can do, you can create a table function for it, which is of read only type, and then you can call that table function. What will happen with this in terms of best practices? Your procedure length will be very short. It is easier to understand, because what happened when we see lengthy procedures being written, it is difficult to do the debug. When we know, okay, we are calling one table function again and again, we know that okay, what this table function is doing, we can check that first, and then we can say okay, this is what it is happening in brain, this is how it is processed. So in that way, the length will be reduced and analysis would be easier, and debug would also be easy. Then table functions, these are as again the what can also have a source, can be used as a source for your graphical calculation view as well. Consume data from tables, models, function, predictive algorithm, etc. So predictive algorithm is a new concept which basically been used for your mostly for your unstructured data in today's era, how we deal with that. So predictive algorithms are very interesting topic. Then we have procedures. We have read about how we can select our data, how we can write case statements, if and condition, stuff like that. Now we are more interested in our DML operations. Okay. So any questions so far? I will be covering procedures also today only, so that in the class we can go ahead with the lab activities. Okay. So yeah, no questions so far, right? Let's come to the procedure part. So procedures are basically just like other thing, a group of SQL statements, and we try to achieve certain operations out of it. Okay, certain result cross applications, and stored procedure can return data in form of output parameters, integer or char, or also a cursor variable, or it can also set in select statement which is stored by other procedures. So what happened, we also have a procedure, we also have a feature available within a HANA where we can create a procedures and we can create them as read only. Okay, when we create them as read only, in that case what happened, those will be treated as table function itself. So we are not going to use any DML operation, we are using only DLL operation on top of them. If a lot of views, okay, this is they have given how to use, like, create read only table functions, procedures, and then we can call them again and again and make a effective practice. Then scenario 2 is, the other scenario is when you wish to create a code that simply delete, insert, or update the table function would become inadequate as it doesn't support. This is the best use case to use store procedures in HANA, and we would take up we'll take up an example. Another thing is sequences, DB triggers, and synonyms. So what is happening here is, it has given us the basic thing how it should be done. So we are saying our value should be incremented one by one. We need to provide schema name. We need to give the value like it will do what increment 10 by 1. Start value we can also give, let's say 10. In this case, what will happen? The first value in a table would be 10 instead of 1. Then max value, after which after this this will be coming, message will be coming up. Okay, so we can define some random value here. Minimum value can be used for descending, that okay, usually it is incremental, right? But we may come up with a scenario where we want to reduce the sequencer. So in that case, we can just give min instead of incremented by. So these are basically functions defined within a HANA. And yeah, so this is the only place till where we are supposed to, with the help of these, we will be able to define our sequencer. Okay, so we use whenever we are going to create entries into some physical tables and we want to write them in some particular sequence. Okay, let's read about a sequence is a set of integers 1 to 3 that are generated in order of demand. Sequences are frequently used in database because many applications require each row in a table to contain a unique value, and sequence provide an easy way to generate them, right? So let's say in your data you don't have any unique value. Okay, so while getting your data itself, you can create these generators so that it will be handled and we have a unique column. SAP Native HANA introduction to SAP HANA SQL. Okay, right. So we understood this. Okay, let's talk about it. What is definitions and manipulations? Schema definition. What do we do here? We create the schema, create schema, your schema name, and that's it. Okay, then data manipulation. Okay, let's go here in the home SQL. Okay, so the first very basic statement is that you have your database designed, you have your tables and everything on top of it. So we'll create a table. So what we are doing, we have already system defined schema Z HANA 0. We are creating a table into it. So what we are going to do, we are using the approach of SQL only instead of your CDS. We created employee table in CDS, right? This employee table we created with the CDS approach. What we are going to do, we are creating, as we are reading about SQL, so we are creating a table customer with the approach of writing a SQL scripts. Just click on activation. What we are doing here is, let's see this. So a row has been created where a table has been created where number of rows are 0, because as of now there's nothing, right? So a new table is created. What will it will have? I'm writing a 4 columns: sequence number, customer, period, and revenue. Okay, so sequence number is in integer format, customer is having a length 1 and it is going to be alphabetical, it is varchar only. Then you have your period, which is again varchar. You have your revenue, which is in integer. I also want that primary key, which is sequence number. So with this, I have added the concept of primary key as well. Let's go into our catalog. We have 4 columns: integer, length, where we have defined integer, we don't need anything to be defined. Because it's a primary key, so it will always have a value, it cannot be null. If we try to insert anything without the value for first column, it is going to throw an error. Okay, let's do that. We want to insert some data. I will remove the first column value. Okay, and now try to execute. It's showing syntax error. I'll remove this one and now try to execute. Not enough value, this for column 1. So basically what is saying that we don't have enough values, right? We should have one more. So like that. And also if we run multiple this thing, then we will be encounter the same thing, that the data type is not as requested. And also, okay, let's do this. Invalid string, it's behaving this as a string. So like that. Or if we write null directly, cannot insert null or update to null in line number 1, column number 1. So we basically will not be able to insert null values if you have made it as your primary key.
Hey there! Want to master SAP Native HANA? Our course is here for you. Take it at your own pace on our platform. In this course, you'll dive deep into SAP Native HANA. It's like a toolbox for managing data, from organizing supplies to streamlining operations. Our course covers it all, from basics to advanced techniques, crafted by seasoned experts who know their stuff. Your teachers are pros with years of experience. They're here to guide you and tackle any queries you have. And guess what? Our students love it. Folks just like you have found our course incredibly useful. The best part? It's budget friendly. You get top-notch learning without breaking the bank. Ready to become a SAP Native HANA Pro? Sign up now. For more info, head to ZaranTech's website.
Okay, let's try to insert all these records, and we don't need, it's integer, so we don't need these things. Records. Just insert now. Also, I can see into everything has been inserted. We'll go here, refresh. Okay, I want to show you other things also. We have some tabs here, right? So let's say you have created a partition. As of now, there is no partitions. We have only single statement, single table. But if you have partitions, you will be able to see them here. For each and every partition, you will be able to see total table size, if delta has been performed, when the new records has been loaded, like that. Everything will be maintained here in here, this place, which is runtime information. Okay, it will show you total number of records, and it will show you how much memory this table is consuming, and its data. It's helpful when you are stuck, when you feel that, okay, when you're working with SLT. Okay, even with SLT, we can check the records count directly here and then see, okay, how it is been there. And if on SLT partition has been done, this place plays a very vital role. So we'll again just try to see if data looks good to us. Yeah. So in this, what they're saying, source file, define import properties. Source file, we'll go here. I think they have a change of version. The version which has been displayed is a very old version. Import location we give here. This is nothing but your source file. Then when we go to next, here everything is on front side itself. However, now when we go to the next, we'll be able to see something like this, file details. It is a delimiter file, where let's say in a one Excel sheet, there is another feature. In one Excel sheet, if you have more than one sheets, okay, in one workbook, so you can select the sheet as well, which worksheet you want to insert. Okay, then you say, okay, it has already has some header, so the import will start from row number 2. Okay, and if you want some specific records to be inserted, we can also give the end line here. Okay, I'm not sure if this feature is already available till today, that we can remove the leading and prefix and end type space if there is any. Then we can create new schema also if it is required. In this case, what they are basically doing, no, they are creating the table also. No, they are not creating table. They are just giving the table name. Like what we have done, we have been inserting to a specific table by right clicking on that table. If you go to this place, which I can show you here. Okay, let's say we are here. Okay, at a schema level. Now we say import. After this, it will ask for your location also, in which location you have your table. Either we directly go, if we go from this place, your table part would automatically be populated. But with this, if we don't have go directly to the table, we just go to schema level and want to insert, then system will ask us, okay, what is your table, what is your schema, so you can provide that. Okay, any one of you have your HANA system working apart from the system what we are doing now, like apart from your test system, do you have your own system where we can do this activity? I'll show you step by step if that's okay, and it's not going to create any problem, then we can do that. Otherwise we might have to wait little further. Select statement distinct. Okay, so shall we use distinct? What distinct does? So with distinct, you are going to remove your duplicate records, just like union and union all. While fetching showing your data, union all will show everything, union will just show your distinct records. So distinct is a time consuming process. However, it is very important to use distinct when you know that you may have multiple values for the same attribute. That time we can use distinct. Okay, but having said so, always understand when you are going to use distinct. If duplicate records are okay for you, that at the time of aggregation and while showing your everything is going to be handled that way, then better you go with the aggregation node and everything will be sorted. Otherwise you can use distinct also. So in this example, what they are saying, they have only unique values for the columns which they are selecting. There is another thing that with distinct, either you can you have to provide the columns name and those columns will show you distinct values. Okay, where clause, it's just like a filter. Okay, that while fetching your data, you want to see data of some specific country. So in this case, what will happen, this is a demo database and they want to see data only for one country, I think Mexico, no, Mexico. Okay, so what will happen if we run this query which has been written here? Anyone, how many records will be fetched? Okay, let's order by. Okay, so order by is nothing but you want to say any descending or ascending thing. Okay, descending and ascending is that you have select everything, but in this case you want that your price should be like in a specific order. When we don't give anything, okay, in that case usually it treated as your low to high, like A, B, C, D, right? So it's from order by. So by default, it is low to high, A, B, C, D, like that. And if we define ascending is something which we call from A to B, okay, in higher order. And if we want the top record should be like the highest value, okay, from Z towards A, then we use DESC, descending. Okay, so what they're saying, select star from here where just order by price, nothing has been mentioned, it go by default as ascending. Okay, I think we executed also. Yeah, so if you can see in the price section, this is 2.5, 4.5, 6 and so on. And let's say we write this keyword and run now. So what's happening, highest value, lowest and so on. Okay, okay, then and equal. And operator is something which comes under your this category, if you remember. Arithmetic operators, comparison, logical. Your logical operators are nothing but and, or and not. So while making any decision, you are supposed to use these operators. And as we might have you might have encountered in your mathematics also, when you want more than one condition to be true and that condition has to be written under your where clause. Okay, what we want, that country Spain and customer name is like. Okay, so they have given one more operator here, which is like operator. What like does is, like is give you the values which are similar to what you have written with your like operator. So they have given where customer name is like G, starting with G, and then you can have anything. So wherever you have this percentile sign, that will be basically could be anything. So in this okay, let's try to understand. They have given this set of statement. They say that customer name should be starting with G. Okay, customer name only. In this row we can see there is nothing. So basically they are checking the entire database, that where the name is. We'll open this, and yeah, so they are saying wherever the name start with G, all these names, okay, where it is starting with G, those will be shown if the second condition, the country Spain. So just let me know, out of these highlighted records, how many will be shown, right? So this is how it works. Then we'll go to OR operation. OR is the country is Germany or Spain. Okay, country is Spain or Germany. So what will happen if we just consider these records? Sorry, like these those 3 records, 4 records only. Yeah, from here to here, how many will be shown in this case? Then note operator, that it should not be Spain. Basically what will happen, wherever Spain is written, that will not be considered, rest everything will be selected out. Insert statement we have already seen. Insert into your table name, then after values you need to give your values within brackets. If it is integer, without anything, without also it's fine, but we can go right away. Then you have your strings, whatever date and everything will be provided. Okay, so null is nothing but basically it's important to understand our null operator. Null operator is used to avoid our nulls also. Like yesterday also I discussed that whenever we have nulls, we can remove that also. We can avoid those in your select just by using this condition, where column name is not null. Okay, what they're doing, okay, yeah, this is here, right? So what they're doing is, first they're checking how many nulls are there. Then in the second condition they are just checking fetch each and every record when it is not null. Okay, address is null. So it's possible that people might have, okay, they haven't, they everything has address. Okay, there could be scenario that people have not provided their address because it's not mandatory. So everything will be fetched here because all the values has address. 91 records, all of them. So you can see all these ABC has been converted to lowercase, first cap, then lowercase. So this is how update statement work, and the important thing need to be remember is always write your where clause and then write this. The reason being, we have seen that we may by mistake or without understanding update the records which are even not required. So update statement, that something is already existing and we want to do it. Delete is simply that you have a condition and you want to delete those records. Top is just like your rank, but it's not without any dividing your set of data into grouping or without on anything. We are just, and even if your data is not sorted, then also whatever will be top 3 records, it will fetch that. Okay, top 3 star from customer. So it will just fetch your 3 records from this place. Then min and max, very commonly used. These are used on aggregation. Okay, like you need to have a data where you have some major values available. Then we'll just select min from this your product, your table, max from your table. Okay, then next is your count. It's a simple one just to get your counts. Okay, select count from how many records do you have. We can do that way, or if you want to check the counts of a particular column, we can check that also. Column name, they are checking they want to fetch only those where the count of product id is where price is greater than 20. Get only those products. Okay, so we'll just execute and see. Only those will be the count is 37. Instead of selecting everything, we are just selecting the count. This is how it will work. Yeah, some average like operator we have already discussed. Sum is nothing but just adding up your values. Let's say quantity, we want to add all of them on a basis of your certain order by also, or group by, or we can directly sum everything, like whatever records has been provided in database, how many is available. Okay, what is the total sum of all the quantities, so we can do that as well. Stop me if you want to check anything in detail. Okay, otherwise it will take huge amount of time. SQL average is okay, we can try to do it in editor. On the table what we have just now created, let's say we want to take the average of overall revenue. So what we can do, select average of column name. Overall average is this. Now let's say I want average of this group by. What happened? We got 3 rows. Any idea why? Earlier we got only 1 and now we have 3 rows. Right. Okay, so in this way we can get more than 1 record on the basis of grouping. Okay, so for anything you can do it. It could be your average, sum, min, max, anything you can do it in this way. Okay, with this concept, let me just introduce your I don't think they have made. No, they are not covering it here, so we'll just cover that also. We have a concept of window functions, right? While doing your checks on overall material, there was something with the window functions.
Hey there! Want to master SAP Native HANA? Our course is here for you. Take it at your own pace on our platform. In this course, you'll dive deep into SAP Native HANA. It's like a toolbox for managing data, from organizing supplies to streamlining operations. Our course covers it all, from basics to advanced techniques, crafted by seasoned experts who know their stuff. Your teachers are pros with years of experience. They're here to guide you and tackle any queries you have. And guess what? Our students love it. Folks just like you have found our course incredibly useful. The best part? It's budget friendly. You get top-notch learning without breaking the bank. Ready to become a SAP Native HANA Pro? Sign up now. For more info, head to ZaranTech's website. All right, let's test your knowledge. Here's a question for you. Which programming language is commonly used to develop applications for SAP Native HANA? Option A, Java. Option B, Python. Option C, ABAP. Option D, SQL. Take a moment to think, and when you're ready, choose the correct option. Remember, each choice holds a key to unlocking the answer. Good luck! Type the correct answer in the comment section.
Yeah, windows and string functions. So window functions are just to perform or allow an operation on a set of input rows. Okay, window function are very important whenever you want to do things in a script way. When you want to use your rank operations, you want to, instead of doing a rank nodes in a calculation view, you want to do it with the SQL queries. That comes under window functions, that you are dividing your data logically into something and then performing an operation on top of it. This is how your window operations has been done. Okay, yeah. What we are doing here, we are selecting our customer, periods and revenue, where we want sum of revenue on the basis of customer. We have, in this example, we have done average of revenue, doing a grouping on customer. What he is doing, partition by customer, that will be your basically overall result. He wants, that person wants to do the summation and want to select remaining columns also. Okay, so I'll create one more statement, select. Okay, so what we are trying to do is, we are selecting everything and giving this also. We need to give few things in your grouping as well with the numerical values. Okay, so result one is, you have done your grouping on the basis of your customer, and then you have summed up your data. Okay, is it clear till here? And in previous case, what we did, we basically just clubbed and showed you customer and the summed up revenue. Here we have remaining things as well, but the summed up values for each and every customer, irrespective of their periods. We are not considering the periods column at all, for what time frame they have done it. Any doubt or any other thing you want to check here? I will ask some questions now on the basis of what we have done so far, to understand better way about your grouping. Okay, I'll give you a scenario. Let me rerun that. I think we executed this one, right? Okay, I'll before this, I want to show you one setting. It's very useful. What is happening now, whenever we are running any SQL, the previous result is going and the new result is coming up. Is that correct? Now let's say you are doing some analysis and you don't want to run SQL again and again. You want to see, okay, once I run this, the second result should come after this. So there is a setting. Go to Windows, under your preferences, write SQL. Go to this section where runtime SQL. You can see here there are a couple of checkbox. Okay, so this checkbox says that clear your SQL console before running any. So you see, console, clear each and everything, this area, before running a new statement. We don't want that. Sometimes it's important to understand what has been, how much runtime has been taken previously. The only thing which is good for us is close result before SQL statement execution. We don't want that. We don't want to close the result. Okay, so we'll just apply and close. We'll do this. First result is already there. Second, let's say I will just run this statement. Okay, both are here. Yeah, this is where we stopped. So we'll resume from this point. Do you think there is any meaning of having same customer, same revenue values? Okay. The only thing is you have different periods. Now I want to sum up my data in such a way, basically a cumulative sum, that for January, okay, I'll go and do just, okay, this is my data set. So I want for January, it should be 1000. For a customer April, it should be 2000, addition of these two, and so on. So with the window functions, how you will do it? Okay, try to answer this. That how do I want? We need, along with the periods, that whenever the periods getting changed, it should add into your next row, cumulative, 1000, 2000, addition of these three, like that. 9800 for March. Okay, we have April into Feb also in between, so Feb will come here. So like that it should add. A hint is we have learned something about group by. And we also have learned something about order by. And you can let me know, it's not only this format we have to do, there are other practices also which we can use to achieve the same result. You can take help of these two things, order by, group by. Tell me, I'll keep on writing it. Okay. It's basically a string. So with string, we are not able to maintain in a proper way. It is reading first alphabet A is coming first. So that this is how it has been happening here. Either we can write a proper, years or numeric value here to make it in a proper format. Having said so, it's A. So it's reading it as a first place, 1000. Then it's adding. So basically, if we have a proper time frame, let's say, in that case it will read in specific format, 2023, 2024, let's say, like that we have it. So it will read. The idea here is of group order by is addition of your revenue, but in such a way that it is happening at your second level also, which is your period, to make it more reasonable and logical data. Yeah, if they want to consider period also, then we have to make it under order by instead of group by, because if we do group by, customer and period both, what will happen, it will not do a cumulative sum, it will just consider this as a one set of grouping, and it will add. We can check that also what will happen. So in this case it will now go till 11,300. Okay, so we had 3,400 only. We got, sorting has also been changed, 78, whatever way it was earlier, the similar values we are getting here. The reason being, this together for each and every record is making a unique combination. You got it right? If we could have a scenario that, okay, B Feb, both of them have the same records, in that case these two will club together. Instead, like 3,400 and this and those will be clubbed together, and one values will be visible for both of them. So we are going to continue this topic, introduction to SAP HANA sequels. Okay, what we covered is simple introduction, working with sequels, creating and using functions. These things we are going to do today after completing our W3 schools functions. Okay, average we have seen the like functions like sum, average, and those things. Okay, so the like operator is simply, I'll give you a real time scenario what happened. Sometime the business wants to see, let's say, a material which prefix and suffix could be anything, starting and end could be anything, but in between it should match with the text which they are providing. Okay, in this case what we can do, we can use like operator. So how like operator works is, you need to give percentage sign wherever you are not sure about the text how it will be. It could be text, it could be a numerical value, anything. Okay, so for everything you'll be giving a sign of percentile, and then you will, if you know a value which should which should be there in your overall value of your record, then you will be giving that constant value. After that, if it's again some values, some undefined values there, you will be giving percentile. Okay, and underscore and these things are basically space. So let's say you have business says you need to figure out all those values where it contain something like t, anything before t, then underscore, s, then this. Okay, so what we can have, we can have anything at the place of underscore. Okay, and then this is the place, this is how it should look like. So this is what they are talking about. We'll see this with some examples also. They have a given that it should start with a. Okay, let's do this exercise. So these things are coming in customer name. Let's say now a r underscore u percentage. Okay, what we are expecting here, these are the customer name column. Basically we are saying one more value is there which is not known to us. Okay, so if we give percentage, we can have a lengthy value. If we give underscore, only one value we are expecting. If we give more than one, I don't think we have any value for it. Yeah. Okay, so in this case, how many underscore we are giving, that is the only place we are providing. I hope that is clear to everyone. Okay, then after like we have wildcards. So wildcards are basically same thing, that whatever can be there and we are searching it. Okay, then in operator. In operator is basically to let you know if, just like your input parameters. Okay, in input parameters what we are doing, we are giving a list. Okay, with the input parameters, sometime when the value could be more than one, there also we are basically using the functionality of in operator. Okay, so what happened is, instead of giving a equal to comparison, basically we can, business can ask, show me all those data which hold certain set of values. Okay, for example, what we are doing here, we are saying show all the records of customer where the country is Germany, France, UK. So all those records will be fetched. Execute this. We have 29 records where if you'll see the country, it will be Germany, UK and France only. Yeah, so this is your in operator. Between is very important, and it's basically to give you a range instead of giving values individually, Germany, UK, stuff like that. So basically Germany, UK is your string values. So you can't provide a range over there. However, your numerical values, you can give a range. System knows about it. Okay. So you can give like 10 and 20. So the operator works like select star from product where price between 10 and 20. So whatever between, okay, tell me one thing, will 10 and 20 will also come into your result set? So alias is something that you have created any new calculation and you want to name it in a different way. So we can do it. Even the same column which is existing and you just want to rename, use as. Okay. Then joins. So joins is basically what we have covered, where we have more than one table and we want to join them. We use different joins, and we can also do a join on the same table. Okay, calling it 2 times. So this is if we are writing in scripted way, this is how we do it. Select what all columns. Instead of selecting first, how we write basically. For this, we from basically how I usually start is myself select star from my first table name, whatever join conditions whatever join type I have to use. Let's say inner join, customer on orders. So what I did basically, instead of writing exact column names, what all I need from whatever table, always write your always write your join statement. Okay, where and how, on which columns you want to have a join. So in this way, you will be able to understand what all alias type you have to use. Basically, like order has been given. Okay, we can give a name also here, like let's go to try yourself. We can do like this also, order. Now you can see that whatever column is from this, that path or the table name has been provided. Correct? This is a keyword. This is the main thing. And this, okay. Now let's say you have these two columns, these two tables, and the columns what you are fetching, the names are different in both the tables. Okay, the joining condition is okay. You have joined on the two things, but here what you are selecting in your select part, the columns name are different. Do you need to give this prefix? If your column names are same or different, whatever, when do we give this prefix, and is it mandatory to give them? Performance wise, it will be obviously inner will be faster because system will be having complete idea what exactly you want to do. So we prefer joins over these where clauses, because in this we are not sure system is not very clear, like okay, you want this and this, and then you are joining two tables. Here also you are joining two tables only at the end. The syntax only you are using different. This is the reason they have not given a editor. Okay. Store procedure, as I discussed, store procedure are basically used to do anything in your while doing your DML operations, insert, update, delete. Okay. So we use procedures. Then we can schedule them within a HANA capabilities. If a set of statements want to be run at a specific time, we can create a procedure and schedule it with the XSA jobs engine or with any other outside tools available to us. Comments, how do we write comments? They have given double hyphen. However, in here with HANA, we can write with the help of asterisk also, or we can comment out anything with the help of / asterisk. Then set of statement will be commented out. Wherever you want to stop comment, you can write asterisk / You must be knowing about it, I assume. So if you want to comment out block of statements, you can use this. And if you just want a single statement to be commented out, you can use this. Okay, fine. SQL operators, this is what, if you want to add anything, you can use this. Subtraction, multiplication, division. Percentile is for use for something different in our SAP HANA. and operator, or operator, this is what, and then you have not equal to operator, less than equal to. These we have, I think, already checked couple of them. Okay, the database statements. So basically drop statement is to delete the entire database. Database is nothing but your table. Okay, then backup, do that. Drop table. Okay, drop table is something we talked about. Create table is also we have done already. Alter table. Okay, we have this feature available within HANA also. Alter table, that let's say you have a already existing table and you want to add a new column into it, right? So as we discussed, we can create a table with different kind of methods, CDS tables or tables in SQL format. How we do it? Let's say someone has created a table with this approach, create table, right? And they want to add one more table, one more column. So what do you think? They are going to drop the entire table again and then create a new column into it? No. They have a procedure with the alter statement. They can write alter the table name, add whatever column they want to do or they want to add. Okay. So that can be done. In the similar case, if they want to remove anything, remove any column, we can use drop column and then column name. Okay. Renaming is also possible with the keyword rename. It's all these are available within a HANA also. So this is as it is. Okay. So rename can also happen. Okay. And if let's say you want to change the data type or maybe the length, this is a very common thing that whenever the data gets increased, let's say you have a randomly created value into one of the column, and now the engine is creating the values of length 10. Earlier it was of length 8. Okay, so now you need to increase the column length. In that case, we can use modify keyword. But anyhow, all these things would not be required with your native HANA. The reason being, we don't use this practice. What is your functions? How many type of functions we have in SAP HANA? And what is the difference between them, scalar and table functions? Okay, so try to understand why SAP come up with two different kind of read-only concept. Okay, so user-defined functions in SAP HANA capture reusable SQL scripts code for data processing. They accept input parameters for flexibility in various scenarios. UDFs, in the HANA point of view, UDF extend graphical calculation views enable complex data processing. This statement hold true for procedures also. Implementation, basically written in SQL scripts and built using design time flies. Okay, so then runtime execution, successful build, generate runtime objects in the SAP HANA database. Function always execute in the in-memory database, optimizing performance. Okay, so everything about the instead of a scalar or table function, this is true for everything, that all the objects which you are creating are going to store in your design time. Okay, and then during the runtime, we are good with the runtime and design time, right? So successful build generate runtime objects in the SAP HANA database. So a, a table kind of a thing, like a table is a thing which is defined and been stored. We don't have to do it again and again. Similar way, table function will also be stored in the HANA database. Okay, it's like that. You okay? In SAP HANA, I want to show you. So what I am doing is all the SQLs which I am writing, for example, source, I am saving all of them in my desktop. So the feature is create an editor, Write whatever you want to write, sample sequels. And with this option, so let's say I've done something, this is enabled, save. So first time if you are doing it, let's say I'm doing it for this one, save, it will ask me the location where I want to save it. Okay, then provide that name and select the location wherever you want to save. Okay, and then this will be saved, and you don't have to write those statements again and again. You can just browse. So what you can do,
Hey there! Want to master SAP Native HANA? Our course is here for you. Take it at your own pace on our platform. In this course, you'll dive deep into SAP Native HANA. It's like a toolbox for managing data, from organizing supplies to streamlining operations. Our course covers it all, from basics to advanced techniques, crafted by seasoned experts who know their stuff. Your teachers are pros with years of experience. They're here to guide you and tackle any queries you have. And guess what? Our students love it. Folks just like you have found our course incredibly useful. The best part? It's budget friendly. You get top-notch learning without breaking the bank. Ready to become a SAP Native HANA Pro? Sign up now. For more info, head to ZaranTech's website.
so this PDF, and if I want to share it with anyone, I'll just put it on some SharePoint, another person can access. They can download, and same way they can just go to file wherever they have downloaded. Okay, the connection is not been provided, so what we can do, go here, select your system. No need to write any SQL which is already been created by someone. Okay, whenever, okay, another practice is, some of the statements are always used one or the other way, right? So what you can do, you can keep a notepad ready for it. Write it in this format so that it should not show any syntax error. Save it from HANA Studio itself. Coming back to here, so this is what I was saying, that you can store your SQLs, but let's say you have a set of statement which need to be called upon in different scenarios. Okay, what you can do, you can create a user defined function for it. Now you need to make decision, you will create a table function or you will create a scalar function. Most of the time we go with the table function, because whatever is not possible by scalar function can be achieved by table function. And what is that, we'll be discussing now. Okay, so it's a flexibility. We do have input parameters also which we can call upon, and then you can create and store them in your database. Okay, so they have provided the difference also here, that when we create these table functions or scalar functions, the extension, like we have .pdf, .docs, like that. So here the extension is HDB HANA database functions. Okay, and the same is being used by even in web id. So I told you initially that we are working with the HANA Studio as of now. However, with the XSA concept being introduced, we have something called web id also, which is basically a web page where there also you have the features of same thing, calculation views, your table functions, procedures, table creation, everything is there also, but in the web page console. Okay, then they are saying that okay, it's a read only. As we know, UDF functions are read only. We can't do DML operations like read, write and delete, update, alter. These things can't be performed there. Then one of the common use of scalar function in the calculation view is to drive values for input parameters, either as a default proposal in the pop-ups that can be overwritten by the user, or as a fixed value that cannot be changed by the user. So what they are saying is that, okay, first thing I think they haven't informed as of now is the scalar function only generate a single return value. It cannot generate the entire table. Okay, only single values can be generated with the help of scalar functions. So this is why if we have to generate any specific column, or we need to give, as they have explained, right? So if we want to deal only with some columns, then we can use scalar functions. That is again with the read only. Okay, you can do a little bit of here and there in the expression format. The select x multiplying with y. Okay, so you can just select, you can't actually insert into anything. You got it, right? Then scalar functions, example of scalar function is to return the current date. Yeah, so obviously just example, because in SAP HANA we have a function already reserved word already defined, that is current date. Okay, with the help of that only we can return the current date. However, scalar function, just to return any single value we can write them. Okay, and scalar function return one or more parameters, but each parameter always have a single value. Scalar functions often have one or more input values. They can have more than one input values. Okay, they can select multiple input parameters, but input parameters, or while calling them, let's say select star from scalar function, within a bracket you might need to give some values 1 2 3 like that. Okay, so in that case scalar function may receive more than one, but will return one value. That's something with the scalar functions. Okay, function this receive two inputs, result into add column, result module. Okay, so languages, so what they are doing is begin x, so whatever x plus y and x multiply y, so single value they are returning, right? If you want to return more than one record, that's not possible with your scalar functions. More than one row, or more than, or maybe a table result, that is not possible with your scalar functions. Okay, return result, return table. Then table functions are used to return a tabular form data as opposed to a single parameter. Okay, this is the reason we will go with table function, right? Then the tabular data sets are consist of one or more columns, because when I started SAP HANA long back, so these kind of questions always used to come to me, like why do we have these many things doing the same purpose? So the reason is, yes, we can create same set of things, the result would be different. Yeah, we can have only single thing, or we can, okay, another question is, then why scalar function was defined if it's only single function? Because if you are driving a table, it means it is going to take a huge time. And let's say you're driving a table output from a table function, but at the end you just need a one column value. What would you prefer? Obviously you would prefer a scalar function for that. Yeah, scalar function for that. So in that way we define our technical objects. For a business requirement, what technical object we should create. And trust me, when we have a knowledge what technical object should be created, our performance will automatically going to be good. Okay, yeah, so tabular data set can consist of one or more columns and usually have multiple values. That's pretty much normal. Then table functions are commonly used by modelers to define a customized data source in a calculation view. Okay, that can be clear with example only. Refer to the function wherever a data source can be defined, such as in a calculation view, projection node, or a join node, just as you would include in a table. In fact, it might help to think of these dynamic tables. Okay, so let's say you want to create a dynamic SQL. Okay, I'll create that example for dynamic SQL. So dynamic SQLs are basically um, that same set of SQL has to be created again and again when different values has been provided. Okay, let's try to understand this as of now with the help of sheet. And all of them has to generate the same set of SQL. Okay, I've created a very like normal SQL as of now. So what is happening here is, for all these three systems, what user want is select all those customers, select all data from the customer table, okay, where your customer IDs are available in 1 and 2 system only. Okay, yeah, so now if you have seen, let me try to increase the size. Is this asterisk sign visible now? So basically what we're trying to do is that we need to generate 3 SQL statement, and this asterisk should be changed automatically. Okay, so what will happen in our HANA table function, we will be writing only one SQL statement. We will be receiving some value from the input parameter. Okay, or maybe within a table function only we might have defined a variable which holds all these values, and automatically 3 SQL statement would be created. I have written it this way, but ideally when writing the SQL statement in table function, I'll be using it with some variable name, and with each and every variable being passed, these values, these table functions would be created, this SQL statement would be created dynamically. Yeah, but the idea here is this is being used whenever the same set of SQL need to be generated with little bit of difference. And the difference is not in your select query or maybe the SQL part. The difference is in your values being generated or maybe values being used from your input parameters. So usually this is a very real time scenario that we always use table functions whenever we have something from the input parameter coming up and we want to create a dynamic SQLs out of it. It's a very time saving. We have table functions. Try to jump to an example if they have any. Yeah, so your function just like your scalar name, then they have a value with this, and it's a data type is char. Okay, and then they are returning a table, a value integer and b value integer, 2 columns, and then your SQL script begin return, select this from my table. So all the values which are there in that table will be populated instead of single values. Okay.
Hey there! Want to master SAP Native HANA? Our course is here for you. Take it at your own pace on our platform. In this course, you'll dive deep into SAP Native HANA. It's like a toolbox for managing data, from organizing supplies to streamlining operations. Our course covers it all, from basics to advanced techniques, crafted by seasoned experts who know their stuff. Your teachers are pros with years of experience. They're here to guide you and tackle any queries you have. And guess what? Our students love it. Folks just like you have found our course incredibly useful. The best part? It's budget friendly. You get top-notch learning without breaking the bank. Ready to become a SAP Native HANA Pro? Sign up now. For more info, head to ZaranTech's website.
We missed one slide. So what they're saying is, as an example of table functions, consider that you may need to read data through a table containing sales order so that you can find open orders that recently been created. So they are giving a condition. Let's say there is a column with the value open. So all those will be picked up. So conditioning has been done already. Filter has been applied already. Now the data used for the determination of the required order is based on the input parameter. Okay, so we'll pass that input parameter from your calculation view. Then again the filter will happen, and those parameters, those only will be used. The resulting open orders are passed to a calculation view as a data source. So okay, so what we are doing here is, actually the example they have given is pretty much normal. It can be done with the calculation view also. There also we can do the same thing. But this is one of the example that we have an input parameter, and on the runtime we want to change the condition. Let's say right now we are checking only the orders which are open in state. Let's say we want to check something which is closed in state. So all those things can happen, and then it can be given to a calculation function. All the output parameters of the table functions are offered as a column to the calculation view node. If your table functions required input parameters, you can first define input parameters in the calculation view and then use the input parameters mapping functions to map them. So now they are explaining how to deal input parameters coming need to pass to different technical modules. Okay, So with different technical attributes, we need to understand how the mapping has to done. For this reason, what they're saying is mapping will be done. Just a moment. Input parameters. Okay. So mapping, what they're saying is they'll create first in the calculation view, then the same will be in input parameter, then the mapping can happen. Okay. Mapping will happen at the semantic layer. Since SAP HANA 2.0 service package number 01, a new calculation view mode is available, that is table function. It is, again, if someone asks you from when you have the table function feature, is from HANA 2.0 only. 2.0 onwards, we have this function feature of table function. Before that, only scripted calculation view was there. So once SAP HANA 2.0 came into picture, SAP has introduced inbuilt functionality with the help of which we can convert scripted calculation views into table functions, and table functions are better in performance. Okay. It is specially dedicated to handle the different types of mapping of input parameters in a table function. It was possible to achieve the same outcome using other nodes type, but this new node type make it more easier to define define parameters mapping. Okay. Table functions, they have given example with the help of calculation view. What you are going to do, let's say you have a table, fuzzy name, then from your data source column, input parameter, please enter name, that is your input parameter, then the constant value is female. If nothing has been provided, the value is female. So it simply means that the column name is a gender, defining the gender of a person. So the constant value is your female, and it's been mapped that okay, at your input table side, the things are these columns. Okay, so this is how it's been done at the semantic layer. Okay. Now they're defining what is what. Data source column is first add the data source in the to the table function node, then map one of its column to one or more table functions input parameters. Input parameter is what? Choose an input parameter from your calculation view, map it to the table function. Constant is something which you want to define already. Yeah. With this, the theoretical part of table functions, basically table functions, scalar function has been completed. In the next class, I have already started creating some of the sample table functions and those things for you guys. So once it is done, we'll be seeing those things and we'll try to understand how to debug. Debugging a table function is very easy because everything is already in a select statement. You just need to copy paste in editor and then you can do it. But debugging a procedure needs little bit of changes while copy pasting it to editor, or you have an inbuilt tool also like debug mode, debug perspective and all those things. I think those are there already in your curriculum, so we'll be covering them once those topic will be there. This is a simple Node.js troubleshooting. Okay, so we can cover them before that also. So we'll be doing your troubleshooting procedures. Okay. Okay, so do you guys have, like, someone is saying that they'll be doing everything on their own system in development, in their own schema. So do you guys deal with Web ID also? Or it's HANA Studio? Because the lab activities which has been provided is as per latest version of HANA. Can you do that? How you will do it basically? You'll go to your HANA system. Okay. Double click on your system name. This is HANA 2 service package number 6. The latest version. Okay, so this is a similar way you can check the version, what version it is, and it will help you in getting the features, what all features are there in your studio, and in a better way what you can deliver. Okay, so the point here is that all the lab activities has been provided, and the screenshots are provided, and even the statements has been written as per your web id. So if you don't have it, you need to get this thing enabled with the help of the version which we are providing. But when I say so, you can do same things in your HANA Studio also, but you need to know how to do and where to go, which we are discussing in our training sessions. So you can take example from here and create the similar thing in your HANA Studio.
Hey there! Want to master SAP Native HANA? Our course is here for you. Take it at your own pace on our platform. In this course, you'll dive deep into SAP Native HANA. It's like a toolbox for managing data, from organizing supplies to streamlining operations. Our course covers it all, from basics to advanced techniques, crafted by seasoned experts who know their stuff. Your teachers are pros with years of experience. They're here to guide you and tackle any queries you have. And guess what? Our students love it. Folks just like you have found our course incredibly useful. The best part? It's budget friendly. You get top-notch learning without breaking the bank. Ready to become a SAP Native HANA Pro? Sign up now. For more info, head to ZaranTech's website.